Good morning, everyone. Thank you so much for joining us today for the day-long workshop on advanced data visualizations. If you haven't already, I would strongly encourage you folks to download the sample data that I think Scott shared a few days back. It's a huge zip file, so it'll take some time to download. So while I do the intro, if you haven't already, make sure to get that going. Anyway, quick introduction. I'm Nihan Cherpuru. I'm a project scientist in CISL. I manage the visualization services and research group. Let's see. There it is. Yay. So yeah, Wiser, we primarily deal with data visualizations, and we are basically a diverse group of software engineers, student assistants, and people with experience in data visualization design. And we are here to support you with your data visualization needs. I think it's a good opportunity for the team to introduce themselves, and starting with Scott.
Thank you guys for joining us. My name is Scott Pierce. I've been working on Vapor for almost 12 years now. It's very interesting and fulfilling work to support science. I think you guys probably feel the same way about working at NCAR. During my spare time, when I'm not chasing around my 9-year-old and 6-year-old, I like to brew kombucha, and I had started working with glasswork, glass fusing. So that's kind of my hobbies.
Thanks, Scott. And I think today, for the most of the time, Scott would be the one running the morning sessions, like 4 hours or so. So he has a marathon ahead of him. The next one would be Ian. Ian's online. You can unmute and maybe introduce yourself.
Hi, yeah, I'm a student assistant on the Vapor team. I'm a senior at UW-Madison, and I've been working as a student assistant on the Vapor team for about a year now. And I'll be here online the whole time, and I'm looking forward to it.
Thanks, Ian. And yeah, Ian's our student assistant. He's been with us for a while. He's helped us with the Python APIs, example notebooks, and he helps us with the DevOps workflows for Vapor. And next, Matt.
Yeah, hi, Matt Ramey. I'm a software engineer and I specialize in data visualization. Out as much as I can. I grew up in the area and I love living here and I go hiking a lot with my kids. I've been at NCAR for about 11 years and yeah, that's mostly it.
Thanks, Matt. And Matt's the primary person dealing with visualization support. So if you have some visualization that you would like to showcase to the general audience, so he can help you get started on how to design it in a way that you can make it more engaging for general audience beyond the scientific audience. Lastly, Stosh. And I believe Stosh is online.
Yes, hi, my name is Stash Yaroshinsky. I've been a software engineer on the Vapor team for about 7 years now. I'm also a master's student at CU. Yeah, I'm going to be here just also providing tech support and kind of helping field questions throughout this tutorial.
Thanks, Josh. And Josh played a pivotal role with us creating the Python API. You'll hear more about it in the afternoon. And lastly, we have Samantha, Sam from CISL admin team. Sam's also helping us with monitoring online chats and other stuff too. So feel free to reach out to any one of us if you have run into any issues as we go today. Agenda. So how should we do it?
Oh, did we have printouts?
Okay. So for folks who are online, if you follow the URL, it'll take you to our online agenda that shows you. But how do I show it to people in the room?
Let's see. I guess we can open it over here.
Oh, yeah. That's a good idea. Awesome. Yeah. Okay, so we have the tutorial split in a couple of modules. Before lunch, most of that stuff would deal with the graphical interface, so the GUI version of Vapor that we have. And the afternoon section would primarily cover Python, the Python API. And throughout the, oh, there it is. Yeah, and throughout the day, if you have any questions, feel free to interrupt us as we are presenting. We have a relatively small group, so it shouldn't be a problem if you have any issues. And if you run into any technical issues, one of us can help you come out of it. Yeah, you can, I hope, just follow that bit.ly link and you should have the agenda with you. And I think that's pretty much it with the agenda. And a few quick guidelines for engagement. As I mentioned, thoughts and questions are welcome anytime. For folks online, you can use the chat function. We have a couple of us monitoring it. And we also have a Google Doc for feedback and comments. You're welcome to use the chat, but if you have something where, let's say you have some feedback or you have a comment on it, do include it in the feedback document. It's a plain Google Doc, and all of you should have edit access. You can leave your comments anonymously, but if you want us to follow up with you, you can leave your name and contact details as well. And again, if you're stuck in person, raise your hand, and online, you can use the raise hand feature. And lastly, I know all of us are at different levels of expertise with visualizations and Vapor in general. And we also want to hear your feedback as you're going through it. The only thing we ask is to be kind and be respectful to one another. And lastly, we are also available after the workshop. You can reach out to us at vapor@ucar.edu. And lastly, this session is recorded, and we'll share the recording with you all at the end. But I hope you are able to stay with us live so that we can have it more in a more engaging session. Before we begin, a quick activity. If you follow the link in the slide to bit.ly Vapor comment document, I want you folks to put in one word on what comes to your mind when you hear the term data visualizations. Can I pull it up here, right? Oh, yeah, here it is.
Good question. How do you click on a screen and go to
Oh.
You're right. Let me.
Sam, I think that's a great idea.
You just drop it in the chat. We can also share the slide decks with you guys right now.
Why don't we? I can do it once my portion is done.
Okay.
I'll take care of it.
Gotcha.
Yeah. And by the way, this is the first time we are trying it this way. So the Google Doc should have different columns, and you can pick the column where the last name matches that letter. And yeah, feel free to stack your responses. I see a couple of responses related to communication and yeah, visualizations being visual, pictures and visual medium comes into, that's mentioned. when we often post this question, we often get one specific response, especially with us working at NCAR. And yeah, I preemptively put well, it's not surprising given that it's 3D visualization. We don't deal as much with maps, but oftentimes when we post the question, people talk about maps. Maps come to their mind when they say data visualization. Maps are something really interesting because maps are considered to be one of the earliest forms of data visualizations. In fact, one of the first instances where someone used charts to represent numbers, that was done by William Playfair in 1787. He was explaining these charts using maps as a metaphor. So in fact, that book was called an atlas, borrowing from maps. And also, in fact, when he explains how to interpret a line chart, he gives the analogy of a ship going through the ocean and how the line represents the path taken by a ship, and that's how you interpret it. But more importantly, it's data visualizations. I think all of us know what they are, but they can mean different things to different people. You can classify, there are multitude of ways to classify data visualizations. So following a well-known book in this field, these are some of the ways to classify visualizations. So you can classify them based on dimensions, like 2D, 3D time varying, or other dimensions that you can add to it. You can classify them based on complexity. So number of encodings is like how many variables are you trying to fit in one visualization. So you can use color, shapes, or patterns, textures. You can have a mode of design where you have infographics versus information visualization. Most of visualizations that you see in scientific publications, they're more information visualizations, where you take the data and you're visualizing it. Infographics leans more on the graphics. So there's a graphic design portion of it where you take, it is still based on data, otherwise it won't be a data visualization. But there's a fair amount of artistic interpretation that is given to it. So infographics might not be readily reproducible, just given the creative dimension involved in it. And then you have a classification based on reliance on data. So you can have informative visualization where you're just creating a chart and you're presenting the data and you're letting the data communicate and speak for itself, versus persuasive visualizations where these visualizations are meant to move the audience towards something. One example that comes to my mind is the climate stripes. So there might be other ways to visualize the same data. One might call more efficient ways, but then representing it that way helps to communicate that message better. And lastly, the most important one is based on the purpose. So you have three, you can classify them in three types. You have exploratory, explanatory, and hybrid. I'll go a little bit into the details of this one because this is the classification that we use to make sense of what we do in our group. So exploratory visualizations are the tools and techniques that you use early on in your analysis process, where you have some data, you still don't know what's interesting in it, so you use the tools to explore the data set. So once you find something interesting, then you move to the explanatory part, where you take that condensed information and package that into a form that can be communicated with the audience. So it's more, you're not looking at the entire data set, but you're looking at specific areas in the data that's interesting. Hybrid visualizations are getting more popular now, wherein you take a smaller subset of the entire data set, but you also give in some level of interactivity. So your users are not just looking at the visualization that you're presenting, but they have some freedom in exploring. And our group has we do works on all these three areas. Vapor, which is what you'll hear a lot about, comes more in the exploratory visualization type. It's a tool that you can use to explore the data set. It straddles into explanatory. You can create videos and animations to showcase to the general public. We've also done work with explanatory visualization, where we work with researchers to create YouTube videos or interactives to basically convey that message to the general audience. And lastly, the hybrid visualization area is relatively new. We are beginning to work with dashboards and web-based online interactives. We've done work with mobile apps, wherein you're basically giving out some interactivity to let people explore the data. Speaking of Vapor, Vapor is a easy to use 3D visualization software that was primarily designed for folks using earth science data sets. Okay, I can keep going. So Vapor has been around for a long time. I think the Vapor first came into existence around 20 years ago. It started off as a simple volume renderer. It helps you visualize volumes. And it later on grew into complexity. It was most of the development work was led by John Klein, who's now he's the one who manages the whole visualization area, and we work in his division. And the newest version of Vapor is that we released the Python API recently that gives it some scripting capabilities to Vapor. In the interest of time, I won't go into the details, but we will wait for the slides to come back up. There they are.
There is a question in the chat just about
Sure.
asking if there are any detailed instructions to install Vapor. They tried to follow the new link from the email but could not install.
Is this on Windows or Mac OS?
Windows.
And they tried using the community portal? And that should be discoverable in their apps application. in
Yeah, he
Windows.
said they did try but could not find Vapor.
Is there an option to update the community portal or any other updates that might be pending?
Should we take that question offline maybe?
Yeah.
Yes, Carl.
I would just point out something, it's 3D visualization software like you said, but since you do time animations, you could say you're 4D as well.
Absolutely, yeah. Where did you say that? See that in the previous slide?
No, you said 3D visualization software.
Oh, I see.
Yeah.
I got it. Yeah. No, that's a good point. It's time varying 3D visualization, so technically 4 dimensions. And yeah, I'll wrap it up by my portion by saying your visualizations produced with Vapor have appeared in obviously scientific publications, but we've also had instances where we've had visualizations from Vapor appear in digital media, print media from major publications. You can access the QR code, or you can just Google Vapor. I usually try Vapor NCAR, and it should give you the results related to the software and the visualization gallery. With that, I think I'll pass it over to Scott to get into the tutorial portion of it.
Great. Let's see. Joey, could you go to part 0 of our slide deck? Great. So I guess I want to start off, again, my name is Scott, and I feel like the question we have to answer is why even consider using Vapor? There's all sorts of different 3D visualization applications that are out there. They're not our competitors, but they're kind of our complements, I consider them. On the screen, you should see, well, I guess I have the deck up here for now, before I do exit Vapor. I'll just do it up here for now. But there's also ParaView, Visit, also excellent open source 3D visualization applications, and then sometimes scientists or visualization scientists like Matt will use tools like Blender, cinematic rendering of scientific data. But the problem is that these applications like ParaView, Visit, and Blender are going to foist a whole world of different options on you from the second you open the screen. Loading data is hard, finding your parameters is hard, and it's a steep learning curve. Vapor's niche is that we are dedicated to the geophysical sciences. We trim out all these extra features that aren't typically used by geophysicists, And we organize our parameters and our settings in a way that's intuitive and easy to follow. If you compare the two, I think you might agree, I'm biased, as a developer for Vapor, but I think this is much more approachable than what we see with ParaView. You can kind of think of it as a learning curve. The time to get proficient with Vapor is much shorter, and you have a much steeper learning curve than you do with something like ParaView. It's going to take you a lot longer to produce something similar than you would with Vapor. Now, that being said, ParaView can do some things that cannot be done with Vapor. So there's room for both applications, but for geophysicists, this is an excellent starting point. You guys are focusing on your science as it should be, and by using Vapor, you can get 3D visualizations on the table much quicker. And so here's a cartoon that kind of reminds me of this. I don't know if the audio is going to come through. Let's see. This is, well, don't do that. Well, let's see. I'll have to try. Could we advance to this slide? And could we play that video, Joey?
Just press any key.
I think we've all seen it.
We get it.
So that's why, in my opinion, Vapor is a good tool to use. Joey, could we go to slide deck number 1? Vapor Workshop, part 1. Okay, so could I get a showing of hands? How many people here have Vapor installed and are able to open it to see a screen that looks something like this? Just about everyone. Okay, anyone online? Thumbs up online. Anyone that's having trouble online, please relay your questions to the chat. So let's see. This is the intro screen. There's really nothing there. Vapor disables everything except for one tab over here called the import tab. Before I go into Vapor itself, I want to talk about this morning some of the workflows we're going to go through. We're going to start with Hurricane Katrina, a worst simulation of Katrina, and go through some renderers there. We're going to then move on to a tornado, a CM1 simulation of an EF5 tornado, modeled after the Joplin tornado, I think that was in 2013. After that, we have a particle simulation of an idealized simulation of the Tunguska eruption that happened in 2022. And if you guys get lost, and if you fall behind, the workaround for that is in your data directory. If I go to what I have, you should have a directory that you extracted all your data into called April 2025 Workshop. In that directory, you're going to have 4 subdirectories, one for Katrina, one for the tornado, and one for the volcano. And within there, you're going to have a file called a session file, a VS3 file. If you go to Vapor and click Open Session, you can select one of those files, and that will take you to the end state of that section of the tutorial. So for example, if I click on Open Session, yes.
I don't think the folks online can see you, right? They're seeing the slides.
They should be able to see the presentation screen and the slides. Is that right, Joey? They should be. I'm getting nods.
Okay, I think you can continue.
Yeah, I can only see the slides.
Ian can only see the slides. Can you see, it looks like in the top right corner, well, I guess you can't see the screen. There should be an option to view, to pin. So they can't see the main presentation screen, I guess, is what we're hearing. But they can't see the main presentation screen.
Someone did say they were able to change the layout to see both.
Okay, so it sounds like in the layout tools of Google Meet, there should be a way to pin the different screens. You're going to want to pin the slides as well as the main presentation screen, which is being shown right now with those settings. So I guess it's the pin button to unpin or pin. You're going to want to pin the slides and pin the main presentation screen. Okay, the other screen is under Scott Pierce. Okay, that makes sense. So the main presentation screen will all be operating Vapor, will be under Scott Pierce. And then the slides should be under UCAR or maybe main seminar room. Or Joey Ehrman, maybe. Joey Ehrman has the slides, I have the application.
Yeah.
Okay, so if we're still caught up on that, please raise a question in the chat. So if you fall behind, to catch up, you're going to navigate to the session file of the current section. So for example, if we're doing Katrina, you fall behind, open the Katrina session file. And then in each of my slides, well, so once you open the session file, you'll see a screen like that. That's the end state where we're going to. And then in the slide deck, there's going to be a title bar with the data set we're dealing with, in this case Katrina, and then a bookmark. To open a bookmark and step back to the slide that we're presenting, you're going to go to Edit, Load Bookmark, and find the bookmark that matches the title of that slide. So that bookmark is Q Cloud. I would go to this bookmark right here. And that would bring me to the state that we're at in the slides. Alternatively, you can just keep the original session file and follow along without retrieving that bookmark. So here are a couple slides of what we're trying to achieve with Katrina. You can see we have a volume rendering of Katrina with some wind barbs and a map. And here's another shot of the volume rendering. And so to get started, we're going to, I'll restart my application and start from scratch. So close Vapor, reopen it. You should see a blank screen like this. All tabs disabled except for import. In the import tab, we're going to click on WRF ARW, that's our data type, and then select files. Navigate to our downloaded data directory under Katrina, and we're going to select all WRF files that are included. And real quick, going back to the import tab, we also have tips down here. If you have trouble getting your data into Vapor, there's some hyperlinks that you can follow to either get one-on-one support if you're really stuck, but also documentation on data format requirements for Vapor. But once we've imported data from Vapor, we can see that Vapor notifies us that we've imported 11 files from a certain directory, and then Vapor takes us to the renderer tab. So what we'll do from here is create a new renderer by pressing this plus icon. And we're going to start with a volume renderer. Here we have a selection of 11 different renderers that Vapor offers. I will click on volume, click OK, or you can double click on the target. We're going to enable the volume by pressing this eyeball icon. And here we have our first big red brick. We're in the variables tab right now, so we're going to select the variable that we're targeting. We're going to change it from pressure to Q Cloud. And now we have a volume rendering of our cloud, a big blue brick. So navigating the scene, once you have this first renderer instantiated, to rotate and navigate the scene, you really need a mouse. And I don't know if anyone did bring a mouse. I have a bunch of extra. Could you raise your hand if you need one?
So the touchpad's not gonna work?
You won't be able to traverse with a touchpad. There is no middle mouse button on Windows or Mac OS. You have to use third-party software to get a gesture to use a middle mouse button. But on Vapor, the middle mouse button is what you use to traverse the scene. Zooming in and out is the right mouse button, and then rotating is the left mouse button. I think I see a lot of MacBooks. I don't know how many USB-C ports we have, but we have USB Type-A mice to go.
Oh, yeah.
But
Can we use the control for a little?
there is no,
Okay.
I don't,
Let me try it. Yeah.
you can try it, but I don't think so. Carl?
I got an error when trying to load all those WRF files, so couldn't get those.
I guess we're not gonna traverse.
Something about permissions?
I guess I don't have the
Where did you
Oh, the other option. Oh, yeah, I can't, I'm sorry. I was gonna say, you can have my mouse, because it's, but it's,
So
it's the same thing, USB, USB-A.
I have.
Now,
Looks like it's
Looks like it. I cannot use
so I
it.
got home,
I don't have the USB-A.
don't think I have one.
I had to use like a touchpad or something.
And then do it however these
Is not working.
seems to have worked. So
Okay.
so we imported that as a new data set, then we'll have two
Okay.
data sets. Click on the second one, so we're just targeting that one that hopefully doesn't have a permissions issue.
All right.
And let me know if
And then what was the, sorry, Ben, I,
you go to the renderer tab. Yeah, we might have some GUI issues there. Okay, looks like most people will be rotating and zooming.
Hey, Scott, if you hold shift and left click, it translates.
Okay, so shift and left click apparently works on the trackpad. So
At least on the Mac.
put these old, gosh, they're not even laserless. All right. Put those down.
Oh, yeah, shoot.
Oh, yeah, there you go.
Rotate is command.
Oh, I don't think you need.
99% of the time, guys, when you're dealing with 3D visualization, whether it's Vapor or CAD software, mice are going to save your life. It's so much more precise. So when you're back at home on your desktops or at your workstations, don't forget this. Let's see, next slide. I guess I'm mistaken on this for the trackpad. Traverse, I guess it's shift, right click will traverse.
Shift left click.
Shift
Or
left.
just shift click.
Just like
One
bunch of buttons.
finger.
See what happens.
If you do two finger, you can scroll or zoom as well.
Okay.
On the Mac anyway.
So there are ways to do it. But those are the trackpad
It's
controls.
doing it for me.
So, okay, we've instantiated a renderer. You'll notice in this renderer table up here, we have our data set that we've loaded in the top left, and we have the renderers. There's going to be a list of renderers that we've instantiated, enabled by this eyeball button. Each renderer is its parameters categorized into 3 generic sections. There's a variables tab, which corresponds to what we are rendering. This is where we pick the variables that we are applying to the renderer. The appearance tab is how we're rendering it. This is where we pick color and opacity and maybe some other specific parameters that only apply to like a barb renderer, for example. If you want 20 barbs on the x-axis, that's where you select that in the appearance tab. Then there's geometry. This determines where we are rendering to. If there's a subset of data you want to look at, you can control that with these sliders, or you can do it interactively with these control knobs in the visualizer. So you can see I've reduced my x-axis by about half. My slider updates to be corresponding to that.
Does that help with speed? Like rendering speed?
It can.
Yeah.
Yeah, you load less data onto the graphics card if you reduce the region that you've selected. And that can be really important with certain massive data sets, like we'll see on Casper. Gosh, I think I mixed up my slides a little bit. I want to talk really quick about the workflow up here up top. We started with the import tab. We got our data in. There's the render tab. This is where most of our work happens. We instantiate our renderers and configure what we're seeing on the screen. There's the annotation tab, where we can add time annotations, axis labels, etc. And finally, there's the export tab, where we save images to a series of files, or we can capture a single image. That's the workflow. It's 1, 2, 3, 4. We get our data in, we create our renderers, we annotate it, then we export our final product. So we are back in the renderer tab, where we're going to be doing most of our work, instantiating, configuring the parameters for our renderers. And in the appearance tab, again, this is where most of our work will be done with the renderers, where we apply color and opacity parameters. What we see right here is what we call the transfer function. This is kind of the beating heart of Vapor. This is what applies color and opacity to all of our different renderers. They all work in pretty much the same way according to this widget that we have right here. On the left, we have the leftmost data bound for our variable, which is 0 for QCloud, and then about 0.002 for the maximum variable. Above that is a histogram. It's a probability distribution function of that variable within this volume. So we see we have a lot of values around 0, and we have so few values at the higher end that they don't even register as pixels. So right now, we're at the Q Cloud bookmark, and I guess I missed a slide. Yeah, I tampered with this morning, and it's all out of order. So I'll go back a slide. What I'm gonna do is, back to this transfer function, all of this, all these colors that are beneath the histogram are what colors are being applied to those data values. So my 0 values are over here, where we have this big impulse. And then as we go higher and higher in data values, we go from white to red. But we can't see anything because everything is being drawn completely opaque. If we rotate the scene, we can't see through the volume whatsoever. So what I'm gonna do is adjust the opacity with this bar here at the top. We have 4 opacity control points, and the higher up this bar is, the more opaque those variable values are. By right-clicking on this control point and dragging it down, I'm now masking all 0 values, slowly ramping up the opacity until we hit a value of 0.00071, where we reach maximum opacity, and then all values between this and the maximum range are completely opaque. You can, let's see, I'm jumbled. Next thing I'm gonna do is go to my transfer function settings. So after we've adjusted the opacity, there's this widget over here, this little gear icon. I'm gonna click on that. I'm gonna get a whole bunch of options from my transfer function and manipulations that I can do to it. I'm gonna load a built-in color map. Vapor provides 3 categories of color maps. There's diverging, which start at one color, transition to white, and transition to another color. Those are good for modal distributions. If you can get your bell curve right at the white point, mask that out, and then ramp up opacity at the tails, you're gonna accentuate the ends of your modal distribution. So that's what diverging color maps are for. We have highlighting color maps, which are good for topography. We'll be doing that later. And then we have sequential. For my sequential color map, I'm gonna pick black and white. My slides have disappeared. There they are. Okay, so there on the slides, you can see where to find the black and white color map. I'll click on that. Now we see we have a big black cloud because we're transitioning from low to high, from black to white. Usually it's the opposite. The low colors of cloud are lighter and the higher values of Q cloud are darker. So I'm going to right click on my color bar. There's an option to reverse the color map. Once I do that, color map is reversed. Okay, so there we go. I click on the color bar and we've reversed. Hopefully everyone can see that. So the next thing we're going to do, if you rotate the scene, and this is true for almost all atmospheric simulations, is that the x and y axes are very long compared to the z. And in order to get the field of depth, we have to stretch the z-axis by a certain factor. There's a few ways to do this, but the most commonly used way is to stretch the entire data set. So to stretch my entire data set, I'm going to click on the data set that I loaded up here in the renderers table. And it's going to give me some information, some metadata about where the data came from, as well as a transform table where I can adjust the entire data set by translations, scales, and adjustments of the origin. I'm going to scale my z-axis, I guess, by a factor of 20 or 30. You can go by whatever you like until you get the aesthetic that you prefer. But once I do that, I can see more of the nature of the hurricane in the z dimension. From this point, up at the top, there's this home icon. This will take you to your designated home viewpoint of the application. By default, that's looking down the negative z-axis, so looking from the top straight down. So if I get lost, if I go too far, and I don't know how to get back home, just click the home icon, and it'll take you back to ground zero. If you like, you can adjust the home viewpoint by clicking on this target icon up here. But I'm going to leave mine as the default because it's always a good starting point.
How did you get to the data set?
That's in the renderers table. So by clicking on a renderer, we get all of the parameters that apply to that renderer. By clicking on the data set, we get the transform table as well as the metadata. Yes, Carl?
I can't get anything but blue out of the transfer function.
Ooh. Cool, and hopefully you can find a bookmark once we get that fixed. So this bookmark is the image renderer, which is the next renderer we're going to generate. So we have a cloud, we want a map to show us where we are relative to land. So to create that renderer, we're going to press on this plus icon in the renderer table. And again, we get our listing of the different renderers that are available. You're going to click on image, and then click OK. And then simply enable it by pressing this eyeball icon. Vapor comes pre-packaged with a set of different maps, but they're not high resolution. If you need a higher resolution map, we have one of those on our website, but the application size would just explode if we had, you know, all these different maps bundled with the application itself. Next thing we're going to do for the image, we can't really see where we are in space. So I'm going to zoom out and then go to the geometry tab. And again, this controls where we are rendering to. The image renderer is unique in that it can be rendered outside of the data domain. We don't necessarily need data to render it. So I'm going to right click on these handlebars and drag out past my data domain on the X and Y axes. And now we have a better picture of where we are in space. Yeah, so that's when you instantiate the image renderer, the default image is going to be here, and so it'll be there by default. The other bundled images that we have can be found if you click select, and oh man, where are they? In your application folder, this will be hard to navigate to. Where's Vapor? Oh, I think my session, so. You mean up here?
Yeah.
So that's the plus button.
Oh, that's the plus button.
And that's what you're going to do to instantiate all of the renderers.
One is spinning the geometry. Little red boxes pop up. Drag it, it just shifts the image, it doesn't expand it.
So that would be a right click, I believe. So if I go to my image geometry, I'm sorry, right click should change the extent. Left click will traverse back and forth. Oh, really? Can you try the session file and we'll see if it happens again. I wonder, are you on an M1 MacBook?
Yeah.
Okay, let's do this. If you're on an M1 machine, Mac's metal architecture doesn't play very well with OpenGL all the time. If you go to appearance under the volume renderer, there's two rendering algorithms for the volume. We can render on the curvilinear grid that's native to WRF. We can also render on regular grids. This one's more robust. And since we don't have mountainous terrain, the regular grid renderer hasn't crashed that we've observed, but it's kind of one of these sticking points that there's not too much we can do about right now, just because of Apple's architecture. So if that happens, try to remember the regular grid volume renderer. All right, where was I? I guess I can see my slides over here. The rest of the classroom cannot. Let's see. That's a good point.
I was thinking.
Yeah, that's a good point. So Vapor will automatically save your session files to a file called Vapor Autosave. If you go to your preferences, you'll find it under this autosave file. So if Vapor does crash, you can go back to here in your preferences and find your last point of saving within 5 changes that you've made. So there is like a fallback, but you probably also want to save your session file manually. You can do that under the File menu, and just above where you would open a session, you just, or just below, you save the session, and you give it a name, and that'll be your save point when you Command S or Control S. That will update your session file. No, that's just setting where your autosave file is. To save a session file, you do that through the File menu.
But then to open it.
Then to open it, that's in the File menu above Save Session under Open Session. Now make sure to go back to the regular grid renderer for your volume, otherwise I suspect that's going to keep on happening. And that's under the Appearance tab. You're going to select the volume, go to Appearance, do the regular.
Yeah, sure, go ahead.
Is that still an issue on the M2 chip?
Yeah, it's all of the ARM64 MacBooks and all of the Mac architecture.
Okay.
That's all the blue is masking the values.
Screen seems to be having some issues.
Make them completely transparent.
Okay.
That should form out the rest.
So I'm not sure where I am in the slide deck,
Okay, all right, thank you.
but we are running out of time, so I'm just going to wing it. Let's do a barb renderer. So to do that, I'm going to go to my renderers tab once again, go to the plus icon, and here's our list of renderers. The barb one's all the way at the top. Click OK on that. And now I'm going to go to my variables tab, and just go ahead and enable it, why not? Just to get something on the screen. Here's the default settings for my barb renderer. We default to 3D variables targeting the barbs. For the barb renderer, there's much more than just one variable we're rendering. We're doing a vector, maybe a color map variable, and different dimensionality. I want to go to my 2D barb renderer, and that's going to drop them all down to the surface. Vapor's going to try to find the first variables that start with U for the X field, V for the Y field, and if there's a W for the Z field, we'll go to that. And optionally apply a height variable. So I guess in my slide deck, so it might be back. Work in progress, I guess. Sometimes you want a height variable in your barb renderer because you might be dealing with mountainous terrain. I guess I must have missed some slides because I had a showcase that I was going to show with, maybe we can get to that after the break when we can figure out the screen's issues right now. But either way, we're going to go to a 2D barb renderer, and we're going to give it a color map variable for speed. Vapor comes packaged with an instance of Python that lets you derive new variables using certain utilities. You can derive magnitude off of a set of vectors. You can compute curl. You can re-stagger your grids because sometimes the WRF output will have different grids for U, V, and W. You can unstagger those onto a single grid and compute wind speed off different grids that way. So to compute this new variable, I'm going to go to the Tools menu, select Python variables, and here we're going to get this. At the top right, we're going to create a new script with the new button. We're going to give it a name. I'm going to call it speed. And we only have one data set loaded right now, so we're going to default to that one. So that's our target data set. We're going to be given a list of input variables that are 2-dimensional and 3-dimensional. Since we're doing 2D barbs, we're sticking to the 2D tab. I'm going to scroll down and select U10. And a little lower, select V10. So those are my inputs. For my output variable, I will also name the variable speed. And the output grid is going to be the same as what the input grids are. This one we don't have to do any unstaggering. We're going to select west, east by north, or south, north. I know this is confusing because the X is in there. That X is the delimiter between the different dimensions of the grid. So west, east by south, north is our output grid. And then, okay, we got our screen back. From that point, well, the script is up there. wish I could enlarge it. There it is. So the script for this, I mentioned that Vapor Utils module that we ship with our Python. We're going to go from Vapor Utils, oh gosh, got some delay. Okay, from Vapor Utils, we're just going to import everything. And then we're going to define our speed variable as speed is equal to mag. That's one of the utility functions that Vapor comes with. And that's just going to be a factor of U10 and V10. We can test it to see if it works. If the test passes, that's good. We can save this script to our session.
Crashed again.
Even with the regular grid.
Yeah, as I was testing, I click on test, it crashed.
Okay, I'd like to check out your computer during a break. See if we can file a bug report. And then we will close the Python editor. So now once we've derived the variable, we can now select a color map variable. And these are all the 2D variables, but at the very bottom is our new variable that we derived called speed. From here, we can operate on our barb renderer just like we would the other ones. I can go to my appearance tab, go to our transfer function. Okay, here's an example of where you might want to hide variable on the slides. There's mountainous terrain, you want your barbs to be following the terrain. That's what I was trying to allude to earlier. And then we're going to mess with the transfer function. For this, I'm going to click on the rightmost color control point right here. And I'm going to give it a value of,
Try to open it.
let's see,
Yes.
go back one slide where I did it before. I think it was 25, that's right, good eye. So you can either drag these or you can enter manual values. I'm going to enter 25. That's going to drag that control point so that my color band is now squeezed between, looks like 1.4 and 25. All of the colors, or all the values above this point are being given dark red. And then we're going to come down here to these settings that are unique to the barbs. We're going to adjust the X barbs by 30. So we just get more. Do the same thing for the Y barbs, give them a value of 30. Z barbs are good, we're only looking at a 2D plane, so we'll leave that at 1. And then we can adjust the length scale. I think the slides I thought 0.3 was reasonable, but you can really just do whatever you like until you have the right aesthetic that you want. The thickness scale, I think I reduced that to 0.4, 0.6. So these are pretty tiny. I'd probably increase the length scale. Let's try 0.5 for that. One thing I'm going to do is disable lighting. If you really zoom into these barbs, you can tell that they're shaded, and they're not perfectly matched up to the transfer function colors. So it's a little bit misleading. They're not the exact color mapped value that we are giving them. So I'm going to disable lighting, and now they have the true representative color that they get from this color bar. And lastly, what I'm going to do is click this checkbox at the bottom that allows us to draw the renderer in front. This superimposes those barbs over the volume so that you can still see them even though they are geographically behind the volume. If I turn this off, a lot of them are going to be hidden. And so by doing that, you get a clearer view of what's happening at the surface. Lastly, yes, Carl?
How do you zoom in now?
That is right mouse. So you click on the screen, the visualizer window, and that should let you zoom out and in. Is that not working?
I use the wheel somehow?
No, wheel will let you traverse. Okay, we're going to run a quick annotation. The most commonly used one is the time step. So under the Annotate tab, we have this time annotation field where we can select a time step number, the user time, but formatted date time is usually what we use for WRF. So we'll click on that. We can see it down here. There we go. We can adjust the font size, make it as big as we like, and then adjust the X position and the Y position accordingly, as well as modify the text color. Real quick, we can add some axis annotations by clicking this, and by default, Vapor reads all of its coordinates by meters from the prime meridian equator intersection. We can enable latitude, longitude annotations with a checkbox below that. And that's what I'm going to get into. We're a little bit over right now, so I just want to really quickly go through the export tab right here, where we're going to capture either a single frame or a time series range. For this, I'm going to click time series range to capture all the time steps. I think we have, looks like 11 time steps. I'm going to save these as a PNG. When you do a time series range, typically you're going to make an animation out of them. So the H.264, when you make an MPEG, it's going to be encoded and compressed either way. So PNGs are compressed, they're faster to write. If you want a single frame, TIFF is going to be higher quality, less compression. But if we're going to do an animation, PNG is the way to go. I'll click on export, find a directory. Let's see, I'll put it in data, workshop, and I'll go to Katrina, make a new folder, and I'll just call it images. And within images, I'm going to give my images a prefix. My prefix will be Katrina. And when I click save, Vapor is going to go through all the time steps, saving files according to your prefix with a number, a 4-digit number according to the time step that they occur on. So Katrina 0000 will be your first time step, and so on through the time series. While that's running, if I go to my images directory, we can see there are my files. And later on in the tutorial, we'll be talking about some of the different ways that you can create MPEGs out of these, so you're not just doing a slideshow like this.
Did you have to track that somehow?
Yeah, so this is a moving domain. In the export tab, there are options to disable that, but by default, if there's a moving domain, Vapor is going to try to follow it wherever it goes.
There are the number of the files you have,
Ye-
individual files.
Right, they're not named according to the time step itself, just the file number in the time series.
So like saving the work outputs with like one file is gonna work.
Yes, right. Okay, so that brings me, I think, gosh, I've lost my track of the slides. Okay, but that's the last slide for Katrina. I think that brings us to a 15-minute bathroom break, and we'll reconvene at 9:30 or 9:30? 9:15? 9:15.
And quick update, I emailed all the slides to you folks.
Yeah, you should get the email.
Do we have any questions? Like, this is a good time for questions too, if you guys have anything to ask. I think I saw.
You can go first.
Oh, sorry, Carl. The Katrina is a famous storm, and you've had, I think, an example with Vapor for a long time. I was wondering if you've made it rerun with higher resolution as computers have gotten faster.
Yeah.
Yeah.
So we'll be doing CONUS 404 later on. That's much higher resolution. We get a peek at Katrina. Well, actually, we're going to be looking at Harvey there. But I believe, gosh, is that higher resolution? I know it's all of CONUS, but I believe it's higher resolution. But I haven't seen a high resolution Katrina simulation since this one was done. This is kind of our old standby. First
What is the grid spacing on that? Do you know? Or?
Yeah, let's see. So I can go to the render tab and I can click on my data set. Okay. Interesting.
I think is it animating in the background?
Maybe it should be done. Okay, there it goes. So if I click on my data set, there's a metadata tab where I can look at the different variables. And my coordinate variables are down here. Looks like my elevation. Looks like the grid size of Katrina is 350 by 309 by 34. So I can interrogate the coordinate variables and get the grid size based on that. I can also go to like my volume renderer. Oh, something's going on with the screen share. Let's see, tab's not refreshing. If I go to my volume renderer, what should happen is this left panel should update to whatever renderer you've selected or whatever data set you've selected. If I go to my variables tab, I can look at QCloud and I can see the dimensions of that variable that I'm rendering as well.
And can you do like 1,000 on one side? I mean, is it kind of standard to do 300? 300 by 30 something?
Yeah, I don't know. I'm not the scientist. I'm just an engineer who works with the data that I'm given. It's whatever the scientist deems is necessary, whether they're doing like
Could Vapor handle it?
Yeah, so CONUS I think is massive. I think it's like, gosh, 1,500 by, yeah, 2,400. It's big. I don't know off the top of my head, but we can go much larger than this. This is like 13 years old. And it also depends on the graphics hardware that you're running on. So when we're on Casper, you'll be able to load a lot more data into memory, a lot more grid, and that's really the biggest limitation. It's not Vapor's rendering algorithms, it's the graphics memory that's on your graphics card.
Yeah, and I think we should look into updating our examples. We usually have smaller examples so that we can package it and send them to folks, but yeah, definitely, if you're on, do we have examples on Casper? Or on Clay, sorry.
Yeah, we have
a high resolution.
We do.
Yeah, maybe yeah, that's something we could put out in.
Yeah.
I just have a question. So I did the export and I see I have all these PNGs for the different time steps. So is there a way in Vapor that I can now just animate over all my times? Like, let's see it moving, or do I manually have to put my PNGs all together, or sorry, what did I?
So you can animate in Vapor itself.
Oh, okay. Oh, that thing there.
There's like these VCR controls, old school.
Got it,
You
okay.
can play in reverse and forward.
Got it.
We have talked about bundling a MPEG encoder in Vapor that would just let you write a movie. You can do that in the Python API. So if you were to programmatically, so the workflow is this. You open up the GUI, you import, you render, you annotate, then you export. But through this process, you can save your session files and then open those in the Python API. That lets you programmatically change all of these parameters in ways that you really couldn't with a mouse. So if I wanted to, in my volume renderer, slowly increase the opacity incrementally by a fraction each time. Something's going on with the screen share, but that should be updating. But the point is that using a mouse for this is, possible, but not precise and highly inefficient. Python API will let you do scans and keyframing, which I wanted to get to. Maybe I can do that after the break, but we're a little bit short on time. Real quick question, Carl?
Yeah, how do I turn the map on?
That's the eyeball icon to enable or disable a renderer. Can you turn it off? Yeah, my screen is not.
It's a checkbox in Windows.
This session actually does go till 9:15 on the agenda, if you want to take a few extra minutes.
I'm sorry, I keep on confusing that. We do have a few extra minutes. So something was going on with my screen share. I'm gonna open that session and get back to my endpoint for this section.
It's not. My screen will change. Screen
Okay, now I should be able to turn off the image and it disappears.
It's a checkbox.
Yeah, like this date is wrong.
Oh yeah, on Windows it
Set
might
to
be
the
a
0
checkbox.
files. See if I can play again.
Image, yeah, press the plus to.
There it works.
Is that Windows 11, Carl? I think that's Windows 11.
Pause.
That's right.
Carl's machine is Windows 11 and the GUI is kind of
So,
discombobulated.
so this seems to be frozen right now.
Somehow the controls are also very.
Does the home button work, or is like the whole application?
Yeah, when I
Yeah, I think we need to.
did that, it just was added to that barb and volume list.
I'm not able to zoom anymore after I did. Or,
You're no longer able to zoom
Yeah, mine's frozen here.
it's the whole thing. Yeah, similar.
after enabling and disabling the image.
Single image. Try the volume.
Yeah. To zoom, I click control.
I mean, just, I can't do anything to the, like,
It's frozen?
I can't pan, zoom.
I'm having the same problem.
Yeah, that's what I just saw too. So we released 3.10 on Monday. This might be something that got past our platform testing.
And it's
This might be some.
Windows and Mac.
Okay, let's take a note of that. One thing you can try is just reopening the session.
Okay, so you're on x86 here.
Let's see.
This might be a bug.
So should I close and open?
Yeah, so is it saved?
David, you said image?
Yeah, you did it exactly how I did it. Out there now it changed.
Don't you have to end capture, is that,
Okay, so
You shouldn't have to.
you don't have to do that anymore?
I can see that's the.
That used to be how it was, right?
Maybe that's what did it though. Let's try it.
Even the image?
Okay, I can see I'm getting.
Yeah, I'm just wondering
I was kind of hoping to show something outside the box.
Yeah, then they get the outside the box thing.
That might be
I'm not sure how to explain how I did it, but I started dragging.
It was
the
after,
boxes on the
export.
edges.
Which box? There's boxes.
I had boxes.
It might be confusing because even this one has the same controls. So the visualizer, so it's possibly.
Okay. Maybe maybe I can show this a little bit more.
Okay. And there my controls have disabled.
Geometry.
Oh wait, no, I can,
I went to.
Looks like it's close into here.
I went to.
is it still capturing?
Oh.
Yeah.
Oh, I see.
See it in the bottom left, it's still loading core data.
That's a progress bar for the renderer itself.
And they're one
Yeah,
at a
and then
time.
now after it's done is when. There is a bug. There's definitely a bug.
Stop capturing at timestamp 10. Yeah, controls haven't been converted back to the visualizer.
You don't have to say end capture anymore, like it used to be.
No, it's supposed to stop, but we're making some changes up to the last minute that might have affected this. Could you file a bug report now?
Yeah.
And then I had to close it and reopen
Okay,
it.
so I can do it with the X on the
That's
bottom.
Because paper does auto save.
I guess this is a good time to mention if you guys find bug reports. Let's see, paper.discourse.group. This is the website you can go to for, just asking general questions or if you have a problem, or if you have GitHub. This is our repository under in-car/vapor. You can submit an issue here. And we do prioritize user-reported issues very highly, so we appreciate any feedback that we can get there. Let's see. Yeah, yes, Carl.
You mentioned the Python interface. I need to run all this automatically hands-off at 3 a.m. from cron and generate a new map for or a new animation for the day. Can I have all the things? Is there in place? Okay.
Everything you can do in Vapor, GUI, you can do through the Python API.
Which is not true of Google Earth, so that's a huge advantage. I can't get up at 3 a.m. and make movies every morning. All right, great, thank you.
Yeah, that puts us at 9:15. I guess when we get back, I guess I gave up after Homer didn't find the any key. So I'm going to, this is the part that I wanted to get to. Vapor's 4 steps: import, render, annotate, export. I think I mentioned that though. Then I wanted to show some animations of what Vapor can produce, just to pique your interest. But either way, that's our break, and I'll see you guys back at 9:30. I'll stick around if you guys have questions, and we can answer those if they come in.
Great, thanks.
Are there any questions online?
Let's see. Looks like we're good online.
Is there any way that I
Someone
can
had the same
maybe change the memory available to the program? To Vapor?
Vapor's gonna hog everything it can.
Okay,
So it'll fill up the graphics card. If you go beyond your GPU, you'll start getting error messages.
but it's probably not the reason why it's crashing, maybe?
No, that's probably has to do with OpenGL and having support for it.
Scott, so are the slides working?
memory you have on your system? Because I haven't had that issue yet on mine. Is mine
I'm
too bad?
wondering if I got the older version of paper, because I don't have.
Me too.
I have the
Export
reviews, yeah.
Yeah, so if
But
you
I
go to-
have 1,000 of
Actually,
Chrome
this-
tabs open.
Yeah.
Probably not literally
This
a
is
thousand.
definitely.
Which chip do you have?
Do you have, is this an in-car computer?
No, but my
Okay, so if you go to,
There too.
Oh, mine is M1.
Yeah.
So maybe it could be a difference between the chip versions. I'm not sure what graphics they are.
Yeah. It did seem to go a little faster once I switched from.
So it does.
In the export tab, there are frame.
Oh,
In this, I'm using a custom output size, 1920 by 1080. That's gonna rescale the visualizer window to that aspect ratio.
Okay.
So if I disable that, I get the full screen.
If you find issues like that.
But it sounds like you're probably gonna want to enable this.
Yeah. Yeah, high resolution is,
Testing to have
these are a little bit expensive.
Is it?
It's the general, as you know.
Yeah.
Do you need something?
I don't think so. Water. I'll run to the bathroom real quick.
Yeah, water and snacks. Thanks to the admin team.
Yeah, I didn't even know that snacks existed until yesterday.
Yeah, I checked with John. So typically, if you conduct workshops, you can get funding for the workshop and that can cover food. Food is very existential, like snacks and
Yeah,
stuff.
I think that normally comes from registration.
Yes, and then we don't have funding for it. It should come from base funds. They're not supposed to be used for food.
I see. Right. Yeah, food has been tricky lately. Yeah, eventually.
It's pretty good, we have groups.
Yeah, there's a lot of different stuff on there. Figured we didn't have too many people, we could do more.
How many did we have in person?
10 plus. And then there was 32 online, but I think a lot of them were, like Joey had 3 people, 3 profiles.
Okay, everyone, since we seem to have a little bit of intermittency with our display panel, I'm just going to show our slides over here on the side. Hopefully that's big enough for you guys to follow along with. But I did want to show some of our animations that go back and kind of show where we've come in the past 25 years. On the left is an animation that was done of the Big Elk Fire in the 2000s. And on the right, we have a recent visualization for Wharf Fire that was done in 2023. It brought a few awards to NCAR, and it was an interesting simulation it's of the East Troublesome wildfire, which was in 2020, and that one kind of made the first responders fighting it pull their hair out. It grew to about 200,000 acres, third largest wildfire within Colorado in Colorado history. And it grew to about 90,000 acres over the course of a month. Then it erupted in a 48-hour period and doubled in size. And when that happened, they had told residents, you probably need to evacuate 10 times. And then the eruption happened, and people stopped listening because they became tone deaf to these alarms. There's like alarm fatigue. So the models didn't predict this at the time. You can see at the top, that's the outdated fuel source that they were using at the time of the wildfire. And it hadn't been updated. The problem is there's not enough boots on the ground to survey the wilderness. I think they can do surveys in Colorado about every 5 years, but there's just not enough people out there to inspect the terrain. So what one of the scientists in RAL did was develop a random forest AI algorithm to use the Sentinel satellite data to classify wildfire fuels in real time. And that resulted in the simulation that's here at the bottom. That much more closely represents the fire that actually happened. You can just compare that to where we were 20 years ago. Lower grid resolution, not photorealistic, as photorealistic rendering software, I would say. But this is kind of just representing the advances in where we've come since then. So that's the East Troublesome wildfire. This is Vapor showing a EF5 tornado simulation. This is the next data set that we'll be working on. This is done by one of our super users, Lee Orff. And here he's using volume renderers to show vorticity and a few other things. And along with a slice renderer at the bottom, showing a three-dimensional variable at the very surface. Lee also uses our software to do what we call path lines. Vapor supports two forms of flow. Path lines, which are time variant. It's like throwing confetti into a vortex. You can throw massless particles into a simulation, into a Eulerian simulation that's gridded, and see where they would advect to. We can also do particle data, which will be our third example. We'll get to that later. But here he is just tossing particles in, massless particles from different areas in the updraft, and seeing how they propagate through the tornado itself. So that's path lines. The other flow setting that we support is streamlines. Those are time invariant. That's just a flow line following a vector field at a single time step. And here's another rendering of the Tonga eruption. We'll be looking at another simulation of the Tonga eruption. This one is gridded Eulerian. The one we'll look at is Lagrangian particle data. But this just shows that massive eruption that happened, I think, in 2022. And this one was done by Matt, I think, a year or two ago. And this is an older visualization that uses a technique that we call keyframing, where you can adjust the camera position, interpolate it, so that it gives more cinematic effect. So you don't just have to go from one perspective, fade out, and then show another one. You can actually give the viewer a sense of where they're going to with different perspectives and then interpolate between those. I think that interpolation should happen any moment now, but this is an ocean simulation using a version of ROMs they call CT ROMs, done by Joan Klepas and Frederick Castruccio in CGD. Here's the keyframing going from one position to another and injecting more path lines into various regions amongst the Coral Triangle, which is an interesting region in the Indonesian Ocean. You know, the Earth has this global conveyor belt, the thermohaline cycle, that takes 1,000 years for a parcel of water to circulate back to where it started. And this conveyor belt plows through the Indonesian archipelago with such force that the sea level height is a meter higher in the northeast than it is in the southwest. So this water is just piling up, causing all this crazy flow dynamics that drive up detritus from the seafloor and cause all the ocean biodiversity that we have in the coral reefs in this area. They were studying this thing called potential connectivity, trying to measure how different reefs are connected to each other, how different coral larvae are being picked up from certain reefs and deposited into others. And the flow is so dynamic here that vortices can be generated off of islands. These vortices can last for decades, have their own evolutionary cycles. There's new species that have never been recorded at the end of this vortex, at the destination, that weren't there when it started. And so this connectivity is being studied to understand which coral reefs are seeding others and which ones are in more need of protection because they're seeding other ones. But later on in the video is another example. Let's see if we can. Here's an example of one of those vortices being formed off of this little island right here. You can see them kind of generate, and they can, take years to spin off and deposit themselves in Taiwan. And then a little bit later, we go to the Liphimatola Strait, which is kind of crazy because the water up here to the northeast is 3 meters higher, but you still get flow that's going into it. So these flow dynamics are like pushing into 3-meter tall water that isn't on the southwest. And so this is the pathline renderer showing how these things advect through time. And keyframing again to another perspective. So those are just some examples of what's come out of vapor in the recent years. I'm going to be showing the slides. I think I mentioned this over here. Hopefully they're big enough to see. But over here I'll be using vapor, and I think the left panel is big enough that everyone can see the parameters I'm adjusting and still get a semblance of the rendering that's coming out over here in the middle. For our next session, let's see. I'm not in that bug state that we discovered, so I can manipulate my scene. We won't be clicking this export option. We have an urgent bug to fix there. But what I'm going to do, either from a very new vapor session starting over, or from opening a new session, which is what I'm going to do here, click on yes to say I'm sure. I'm going to go up to my tornado simulation. So we saw that volume rendering of the tornado a minute ago from Lee Orff. That's in the tornado directory of April 2025 workshop. I'm just going to open that session file. Or do I want to start over? Let's just open the session. Crash. This is part 2 of the slide deck. Yes. So in the Google folder that we shared earlier, that Nihant shared, this is part 2. Right here. So if you want to follow along that way, you can do it there. And I have my tornado slide deck open here. So I've reopened Vapor. We'll do it from a blank slate. So these are not going to be WRF files. This is CM1, which outputs in NetCDF, which is CF compliant. Here's an example of the rendering that we will be getting to eventually. We're going to create a flow, or a volume renderer, a slice renderer. A slice renderer is just a cross-section that's arbitrarily oriented within the 3D volume. You're just taking a cross-section. And then we're going to do streamlines, time invariant, just seeing where these vector fields are going at a single time step. And just I don't know, this is an interesting note to me. It goes back to the history of data visualization. Like Nihant was saying, it all started with maps. Like over 3,000 years ago, I think, was the first documented map, which is considered to be the first scientific visualization, which illustrates to me that visualization is really a core component of science. It can do so much. And these are examples of what are considered to be the first flow visualizations by Da Vinci. So we've been doing flow visualization since antiquity. Over here on the right is a picture called Deluge. Over here on the left bottom is Da Vinci's bubbles. And on the top, I don't know what this is called. It looks like he threw a couch into the ocean and looked at what happened or something like that. So we're going to be loading NetCDF data, CF compliant. Now, CF compliance means a lot, but for Vapor, there's a subset of the requirements of CF compliance that we need for Vapor to understand the grids that we're working with. So in order for Vapor to read NetCDF data, we need coordinate variables for the X, Y, and Z axes, as well as time. These coordinate variables, you can see over here, oh, it's so small. Let me blow this up. You can see that our coordinate variables like time, computed as a dimension of time that we have listed up here, has these attributes. It needs an axis attribute, which can be t for time or 3 for time. It can be numeric or a string. And it also needs a spatial unit attribute. So that can be, for time, seconds since a certain date. It can just be raw seconds or s. And then the coordinate variables for your spatial dimensions need axes as well, such as y or 2 for y axis, as well as a unit, which can be meters, etc. We have more documentation in the slides to our website, so if you have questions on this or need help, reach out to us or check out the documentation. We can help you get your data, your generic NetCDF data into Vapor. So what I'm going to do is select NetCDF CF in my Import tab, then go on to select my files. And those are in the Tornado directory. So I have my April 2025 zip file. I'm just going to select these NetCDF files. And here we are at our familiar screen, blank canvas pretty much, with our imported data set. Let's see. So we've selected our files, and we're going to first approach a volume renderer. So to do that, the same old thing we did last time, click on the plus button to get our list of renderers. And then I'll double click on volume. And I'm going to go ahead and enable it. And get my first big cube with no opacity. We're going to stick to our default variable here, reflected or simulated reflectivity, dBz. Just keep that for now. And now I'm going to go to my appearance tab and start playing with my transfer function. Now, sometimes the transfer function is a little small and hard to work with. So there's this expand button over here, which will pop up a new window, which you can then increase in size. So you can get a more fine-tuned feel for how your transfer function is being applied. I'm going to go to I'm going to shrink this down a little bit. I'm going to go to the settings, load a built-in color map that is sequential. And this one I'm going to pick amp for amplitude. And you can see as I make these changes in the expanded transfer function, they get applied over here in my visualizer in Vapor to the left. I'm going to set the maximum of my data range to a value of 56. And I was just winging it here, doing something that I thought looked good. But this is something you kind of got to play with to get the right aesthetic. My minimum will be set to 22. And you can see my transfer function has zoomed in within this range and recomputed the histogram to show you the distribution of the values between 22 and 56. All the values greater than 56 will have the opacity value that's given by the rightmost value. So this value right here is going to be applied to all values greater than 56. All values to the left of this will have white applied to them, and the opacity according to wherever I leave off this leftmost point on the y-axis. I'll return these. All right, so these control points, you can tell, before we only had 2 control points for our diverging color maps. In this color map, we have a bunch of different control points for opacity and color. I can add new ones and delete old ones, or ones that I've created, by double-clicking. So I'm going to double-click on 2 of my opacity control points to simplify the opacity scale that we apply. And then I'm going to take one, drag it down, And you can, instead of dragging, you can alternatively manually enter the opacity and data values. I'm going to enter a data value, I think. It doesn't matter too much, but I think in the next slide I go to value of 30. So in my transfer function, I'm going to make sure my control point is highlighted and bring this to 30. And I'm going to leave this one where it is. If I click on it, we can see it's at a value of about 54 with maximum opacity of 1. I'll close my transfer function, and you can see all the changes have been applied to the smaller one over here. And we have the volume rendering of reflected or simulated reflectivity of our tornado, which I think exists right around here in this region. But to get a better idea of where that tornado is, let's see. Right, we should be seeing something like that. To give a better idea of where the tornado is, I'm going to create a series of slice renderers to give a backdrop to the edges of the simulation so that we can see the edges as well as the internals. So for that, I'm going to use the slice renderer. I'll go down to create a new renderer. For this one, I will select the slice. From here, I'm going to enable my slice and disable the volume because it's kind of hard to see what's going on with the slice with that volume obscuring it. In the variables tab for the slice, instead of dBz, I'm going to go to vorticity magnitude or vortmag. And then I'm going to go to the geometry tab, again, controlling where we are rendering all of our renderers. So the slice renderer has these controls where you can adjust the orientation according to a rotation value on each axis, and you can also offset it. So if I wanted to go rotate it by roughly 45 degrees on X, I could get that plane, and then I can offset it to the left and right. And as I'm offsetting it, it's going to be rendered in fast mode. It's not going to be full resolution. This is just for responsiveness of the application. But for this example, I just want a backdrop on the bottom and the two far panels. So I'm going to undo my rotation, set that to 0. I'm going to offset it all the way to the bottom. And I've noticed that in this data set, the very bottom layer is low resolution. So if I set this instead of to the very minimum, if I go to 2.999, we get a little bit higher resolution image right there. I think that's just something in the data within the model. Next, we're going to load a new color map. So back to the Appearance tab for the transfer function. We'll click on the Settings icon, load a built-in color map, back to Sequential, and this one, I think I picked Deep. Right there, that greenish hue. Set the maximum color map value to 0.3, so dragging that slider all the way almost to the left. And we can see the gradient a little bit better that way. For our next backdrop, what we're going to do is we could create a new renderer with this plus icon. Alternatively, we can right-click on a renderer and duplicate it. So if we've made like a dozen changes to the parameters of a given renderer and we just want to modify one, we can duplicate it and then just modify that one parameter without having to redo all these steps that we went through the first time. So I right-click on my renderer, duplicate it in visualizer number 0, and this is a little confusing. If I click on that, I want to tell you guys what we mean by the different visualizers. If you look at this main window, we call it visualizer number 0. Sometimes users want to have multiple visualizers, so you can go to this drop-down box at the top, click on New Visualizer. You can see now we have 2 different renderings, but one of them doesn't have any renderers. I have renderers, if I click on Visualizer 0, I have these ones that I've created, but I can right-click on this slice and I can duplicate it in Visualizer number 1, and then when I click on this visualizer, there it is, I can turn it on, it's duplicated. I can then make adjustments and then show 2 renderings at the same time with 2 different sets of renderers. And so that's what we mean when we duplicate it in a specific visualizer. But for now, I'm going to close visualizer number 1, just work with visualizer number 0. we've duplicated our base level slice. I'm going to click on slice number 1, enable it, and then in the geometry tab, I'm going to rotate this by 90 degrees on the x-axis, and then offset it all the way to the edge. Let's see, roughly to the edge. I think I have a specific value for that because the edges of this simulation are a little fuzzy. So it looks like I set it to minus 6.5. I'll shrink this down so we can see the slides. And then it's pretty much the same workflow for the renderer over here. Did I load? I didn't. I started this from scratch. So what I'm going to do is the same process. If you loaded the session file, you can just go to the vorticity slice bookmark. That'll automatically do it for you to save some time. But real quick, I'm just going to duplicate this again in visualizer number 0, enable it, and then instead of 90 degrees on X, we'll go 90 on Y. And where did it go? 90 on Y. Oh, I'm sorry. So I was manipulating slice 1. I'm going to go slice 2, 0 on X, 90 on Y, and then offset it to the very far back. Does that help? Yeah. Okay. Yeah, it can get confusing with these different renderers, so I guess keeping an eye on the renderer table is often a problem. See stuff like that. So we go back to slice 1, U or X, and then minus 6.5, I think. Or something like that. Okay, so from the slice renderer, yeah, here's the bookmark menu. So if you have the session file loaded, you can just go to the vorticity slice bookmark. We're going to do another renderer now. This is the flow renderer that we were kind of looking at. Just, oh, do we have a question?
Oh, no, it's just about 7 minutes.
Oh, okay, yeah, let's go quick. All right, let's do the flow renderer. So like the other renderers, press on the plus icon, double click on flow, and advance my slides. And let's just enable it to see what it's doing as a default. So flow can be computed according to 2D variables and 3D variables. We're going to stick to 3D, and Vapor is going to look for the first UV and W fields to use as a default, but you can change those if you like with the drop-down menu. We can color map the streamlines according to another variable. So we're going to color our streamlines according to vorticity magnitude again. And then I believe next we're going to the seeding tab. So the flow renderer is the most complicated of all of them. We have extra tabs for all the different parameters that apply to it. The seeding tab controls where you are putting your seed points or the origins of either streamlines or path lines in your rendering. You can integrate them forward, backward, bidirectionally, and there's all these other parameters I'm not going to get too far into. Most important thing for right now is to adjust the rake region. So the flow rake is the region that we are injecting our seeds into. You can see down here, our distribution settings are gridded. So we're injecting right now a 5x5 grid of streamlines within this entire region that is similar to the geometry manipulator when we control that region. What I'm going to do is reduce my region to 0.5 on the z-axis. So we're going to be injecting our seeds within the region of 0.015 to 0.5 on the XY plane pretty much. And you can see how our seeds have dropped down to the surface and are kind of being sucked up by the tornado. I'm also going to reduce my X region to 0.5, and you can do this either with the handlebar controllers or manually. I'm going to do it manually to minus 5.0. And now we are injecting our seeds into this region down here at the base, And you can see in the vorticity magnitude field of the slice, here's the main vortex of our tornado, and there's actually a train of them you can see being merged with the main one. We're going to adjust our seeds, throw more in there. So Y seeds we'll throw to 25. Now we can see that vortex a little bit better. And I think finally we are going to load a built-in color map. So right now we're in the seeding tab. We're going to go to Appearance for the transfer function, click on Settings, and load that same deep color map that we did for the slice. And I think we may adjust the color map value again to 0.3. So there's our streamlines. I think I'm running out of time for this example, but let's move forward. Let's enable the volume renderer. And let's not export this time. But once we get that fixed, you'll at least know how to do that. I'm curious if the single screen capture works, but I'm nervous to try. So that is the tornado simulation that we have. You can, of course, play it forwards in time. There's only 5 time steps. These are about 2 GB files apiece. Once Vapor does an initial rendering, the subsequent issuings of those renderings will be faster. So I just played through all 5 time steps. I can reverse it. And gosh, Lee's time steps are just so minuscule. I think he's on like the millisecond time step interval. If you saw the animation, that thing is just spinning like crazy. So the higher spatial fidelity and temporal fidelity in your simulations, the better your visualizations will come out. So there's the tornado example. For the next one, not Katrina, we'll do the volcano. So I'm just going to start Vapor from scratch and reopen it. Over here. I think I'll go ahead for demonstration purposes. I'll open the session. This data is called data collection particles, DCP. So if you do want to just load the data and start from scratch, you would go to the volcano directory in the zip file, and you would select all these particle files. One thing I noticed on Mac OS is that the operating system doesn't, there's 700 files here, and the operating system doesn't register all these until you view them on screen. So let me just demonstrate that. If I go to File, or if I go to DCP, select Files, to my volcano, if I select that, and I want to shift click, I scroll down. See how some of those are gray? The operating system is going to miss those unless I scroll down and make them all register with the file dialog. So yeah, it's a little bit of a manual process, but rarely do you import 700 files. So manually scroll down and just select these and open those. And this is a, like I mentioned earlier, Lagrangian simulation of the Tonga eruption. It was interesting. It caused a ring of turbulence that caused the most lightning strikes ever recorded in history. And so this simulation is analyzing that behavior that was observed. So we've imported our particles. This is our file. Quick mention about the DCP file format. These are netcdf files. Let me make this bigger. And the dimensions that we need are the axis dimensions, 3 axes, a time dimension, and a particle identifier. And then we have a coordinate variable for time. And then we have either our vector or scalar variables. We do need a position variable to know where the particle exists in space, which is a function of time, the particle ID, and the axis. The velocity, if you have other scalar variables, same thing, time, particle ID, and axis. And then you can have scalars like speed, which are one-dimensional based on the time and the particle ID.
Bio is a particle.
All of the particles are contained in one file per time step in this data set, but you can organize that differently if you like. I think typically people do one time step per file. just to make sense of things. Okay, so we've imported our data. We have the data set metadata, but we don't need to apply any transforms. We're going to create our first particle renderer. Let's see if I catch up to myself in the slides. We press the plus icon. And you can see all these Eulerian renderers are disabled. We can't do those except for the model renderer, which we'll touch on when we do CONUS, and the image renderer. So if we do need a map, we can still get it in there, but this data isn't geo-referenced, so that's going to take some hand adjustment to get the right map under your particle simulation. But I'm going to double click on particle and just go ahead and enable it right off the bat. And you can see this is the initial state of the eruption. Nothing's happened yet. So I'm going to advance to time step 400. Up here in the left corner is our time step controller. And there I will enter 400. And here we can see things starting to kick off. The color map variable is under the variable name. We are using speed. So that was the scalar variable in the DCP data set. And these X, Y, and Z fields aren't going to be used yet. You can render particles according to a vector. We'll do that after we just do simple glyphs of the particle that we see here. Next, we're going to go to the Appearance tab and load a new color map. That looks a little more scary. We're going to go to Sequential and do Black Body. Adjust the color map by adjusting the maximum bound to 4.0. And adjust the control points. I'm going to click on this control point, and I think I set it to 1. The next one is going to be 2. Now, this one will be 3. And we'll leave the 2 endpoints as they are. And then the particle radius we can adjust with this slider, make them big or small. I think 1.5 was good enough. And then we get something like that. All right, so let's go back to time step 0 in the initial condition of the simulation. Instead of exporting, we can just play the time series forward like we saw before. Let's zoom out a little bit. And the performance of the particle renderer, I think, is pretty impressive. You can see the times going off as the volcano slowly starts to erupt. And again, the second time you go through the rendering will be faster than the first time after the initial computation is complete. Do we have any questions while that's rendering? Yeah.
Is it caching the tilt of the view or something? If I change my view to have to cache it all over again?
I don't think so. I think it's just caching the data that's being read.
Okay.
I think there you can see the torus, the vorticity that caused all the lightning strikes that they're trying to reproduce in this simulation.
So in the appearance and the color scale, the data value is what? Is the opacity?
It depends on which control point you selected. So if you selected a color control point, it will give you the data value for that control point and the color value for that control point. But then if you select the opacity control point, the opacity's value will give you the data value. And the opacity value will be between 0 and 1. 1 being maximum opacity, 0 being complete transparency.
So when we are adjusting over there, like to 1, 2, and 3 there that we just did, we're just adjusting where the point is in the color, okay.
Right. I think that is about the end of that simulation. Something like that. All right, now let's do directionality, because we did have that velocity vector in the data set. So we're going to analyze that by going to time step 400. in the middle of the eruption. And then down here in the Appearance tab, we have this option, this checkbox to show the direction of the particles. The vapor is going to do its best guess. Hey, we're back at that weird state. So animating was a 2.
Yeah, it happened here too.
Let's open the session file. Get back to where we were.
I think in the interim, maybe we should save the session file before animating or exporting.
Well, I think it's okay to load the bookmark as well, because that should be roughly the same point we got
okay, yeah.
to for animating. So I'm going to go to my open session dialog and find my volcano data set. Open volcano. Okay, now we should be able to go to the Appearance tab. And let's see, I'll load my bookmark. This is Animate Direction. So go to the Animate Direction bookmark, that will take me to this set of slides. Time step 0, let's go to 400 so we can see some of the eruption happening. And then in the Appearance tab, after we made all those changes, change the radius, we enable the show direction. So if we disable that, we get these little glyphs, these little bubbles. If we show the direction, we get these cylinders that point in the direction of the velocity field, which is determined down here through these field variable selectors, which Vapor will try to guess. If it's wrong, then you can select them with the dropdown. And that's pretty much how you do direction. And next we're moving on to CONUS. So I'm going to go ahead and just go through the animation, just show you what this looks like when you do have the velocity field. There is one more thing I wanted to mention. I'm going to stop this real quick. I'm going to go to my Variables tab. This data set, I believe, has about 1 million particles per time step that it's rendering. If you have more than that, and performance is kind of slow, there is this stride option, which will let you select every nth particle. So I think I mentioned that down here. So if I did a stride of 2, the number of particles will be reduced. Looks like my animation controller broke my session again. But just imagine that we're seeing half the particles now that we would be in the rendering that we see. Okay, that's it for the hurricane, the tornado, and the volcano. The next data set that we're going to go through is CONUS 404 on Casper. Can I get a yeah, Neil.
Should we leave some time for questions? Because I think CONUS would start at 10:45.
Oh gosh, so I'm way ahead.
Yeah, it might be a good idea to pause and see if people have any questions.
Yeah, let's pause and have questions, and then we can move to CONUS, because that's going to be tricky, getting everybody on the Casper. So, do we have any questions online?
No. I did have a couple of errors here, but this time it actually gave me a box so I could save the log of the error. So for example,
That's ideal over a crash.
well, that's trying to save my file in a path that doesn't exist, I think.
So, did you do that through the export, or is it trying to save the session file?
The error log, no, unable to write settings in file /user/vapor autosave.
I got the same problem
Oh, you know what?
when I tried to open the bookmark.
No, that's because I set up all these session files on my laptop. So in your preferences, it's trying to find my directory.
Okay,
It's still in, yeah, so if you ever like using somebody else's session files, you may want to go into the Vapor's preferences and then change this path. See there's that path that you guys can't find. So you're gonna wanna change that to the directory when exchanging sessions.
Thanks for helping us debug.
Yeah.
Really appreciate it.
Good question. So one of those examples, like the fire example, it looked like the terrain was 3D. How would you bring in some 3D base data to go underneath?
That's usually included in the simulation.
Okay.
So if let's see, that session's broken. I can probably demonstrate that. So the work area W, I can select files. And I believe in my data, I have these troublesome.
Yeah, I guess the question was, how do you get the two-dimensional data to display with the map?
Yeah, the base data in three. How would you get the base data to be displayed in 3 dimensions, like a 3-dimensional terrain?
Right. So this is a good data set to demonstrate that. And I think we're going to get this data set uploaded on campaign storage. So this will be accessible on Glade if you want to play with the East Troublesome data set yourself. I'm just going to import one file. And so here we have our domain. And then I'll create a new image renderer, turn it on. And you can see how coarse it is when you're really zoomed in. This is one of the maps that Vapor comes packaged with. And we just can't go high resolution, otherwise the application would just be too big. But I have an image, I believe, saved in this directory that I took from NASA's WorldView. So if I go to that directory, troublesome, yeah, snapshot. NASA's WorldView is a pretty spectacular tool. I don't know if you guys have ever heard of it, but if I'm going to go to it just real quick to show you what it is. I think it has like GOES and Sentinel data. Here we are from my last save point. You can enable different layers, different satellite scans, and adjust the date down here at the bottom slider. From here, you can click on this camera icon, select a region, and then you can export it as a geotiff that Vapor can then read. So that's what I did for this geotiff that we have in Vapor. So inside the data set, this WRF simulation, there's the height variable, and that's typically computed and saved. I can click on that. We see everything bump up, but not by much. So I'm going to go to my data set and then scale this by, I don't know, a factor of 4. Now we see the more mountainous terrain. If we wanted to do other renderers, like I think the 2D renderer was used here to show the fire area, I can enable that. It's not offset by height yet, so I can pick the height variable for that one. And then we can see, this is called Z fighting. We're drawing 2 different renderings at the exact same place, and the graphics card can't figure out which one is winning, so it's kind of random. So yes, so if you remember how we scaled the entire data set, we can also transform individual renderers. So I'm selecting my 2D data renderer here. I can go to the geometry tab, again, where we are rendering to, and those same options are provided. We can scale, translate, and adjust the origin. I'm going to translate this by maybe 10 meters on the Z-axis, and they stop, well, they mostly stop Z fighting. There's still some over here, but what we care about most is the fire area. So I'll go to appearance, go to built-in color map, and I think black body is a decent one for this. Right-click it and reverse it. And we can kind of see the burned area surrounded by the fire that's actively burning on the perimeter. And then I will hide all these white values. So now we have the burn scar that grows along the path. And so that's applying the height variable to the image, the 2D data, and then you can also do it with the barb renderer. Same kind of idea. I go to variables and select 2D fields. Oh, there are no 2D fields. I go to 3D. Maybe they're missing in this data set. But if there were 2D variables, I would then be able to select the height variable and then offset the barbs to show kind of what we saw in that animation. Yeah.
Found that the default search paths, like session and data, they revert back to the default anytime you change the bookmark. So they don't stay set.
Oh, because that's baked into the session file.
It's per bookmark. Yeah.
So that parameter needs to be changed in the bookmarks as well. Did you, yeah, so,
Yeah, so I went to the, say the volcano, I went to the last bookmark, and it reset the session file path and the data set path to the default.
right, so open the volcano session. And here we're at the very end. I'll go to my preferences. And then I'll call this something else.
So I was changing the default paths that are not this one, but further down in preferences. Where it has data set path and session file path, those get reset per bookmark.
Okay, can we make a note of that, guys?
Yeah, match, like,
Yes. Okay, that makes sense. Does that make sense? What's going on? Bookmarks are resetting the preferences, I guess would be a way to paraphrase it.
but could you repeat the question for like folks on?
Yeah, so what we're finding is that people are using these session files that I provided that were generated on my computer, but they don't have the same file paths that they're running on their own computers. In order to fix that, you have to change the autosave file, the session file path, and the dataset path. These are all baked into the session file that has been loaded on your computer, but these paths don't exist. So you need to set these to reasonable values. However, after you do that, if you load a bookmark that's at the very start, those will get reset to my path that's on my system, not necessarily what's on your system. So that's a good one.
When I'm creating my own files, do I have to define the bookmarks or are they defined automatically?
Those are, you have to define those manually, and that would be under create bookmark,
Okay.
where the state will be saved according to a certain name that you give it. Then you can later on go to it or delete it if you want it to be discarded.
Okay, so the autosave is just gonna save the latest state.
Right, including your bookmarks.
So then, for bookmarks for this session, it's great for us to go to different bookmarks. But whenever you're actually doing your own visualization, what's the benefit of having a bookmark instead of just hiding or unhiding certain aspect? Like if I had a base 3D image, I bookmarked it, then I added particles and I bookmarked it. Well, couldn't I just hide and unhide particles?
Yes, you can, and that's the easiest thing to do in most cases. But if you're trying to share a workflow with a colleague, or if there's a state that you want to preserve, a bookmark will save that state within a session file without you having to juggle, session file A, session file B,
Okay.
the bookmarks, so just work.
Like if you think you're gonna break something on
Yeah,
the next day.
I better save it now before I, yeah.
Right.
So bookmarks are specific to what you create. I think that's a good question.
Okay.
So Scott, if we, she has an interesting question. So if we save a session file, so if we load your session file with the bookmarks, and if we save the session as like if we duplicate that session file and save it, the bookmarks are not copied.
The bookmarks are
So
resetting.
in the new session file, it doesn't have the old bookmarks.
It will have the bookmarks, but the session file path, these preferences parameters will get reset according to what was in that bookmark.
Okay.
So if you go in and reset these because you're on a different machine, the bookmark will revert to the original state. Unless you create a new bookmark at that point and delete the old one. I think we may have some time to experiment with path lines, which are the most complicated thing to run.
I think we have a break for 15 minutes.
Oh, do we? Am I just reading this again?
The printout had an error on it, so 10:30 should be.
I'm wondering if you should start with SCONUS 404 just because of Turbo like the VNC session, that might take some time.
Yeah, let's do that. Look at a showing of hands. Who has Turbo VNC installed?
I think so.
I think so.
Okay. Or maybe another type of VNC.
It's what?
Okay. Let's go ahead.
It's the viewer, right? No.
That's correct.
Yeah.
On my slide deck.
I have a couple of thumbs up online as well.
Okay. So we'll be dealing with the CONUS 404 data set, which is just massive. I tried to query, I did a disk usage on this directory where it's stored, and Casper kicked me off 5 times before it finally computed 14 petabytes of data, spanning 40 years, 4K resolution, 70 million grid cells per time step every hour. And this is going to be a good forcing for hydrology, meteorology, and climatology simulations. And use this data to force your smaller scale simulations within whatever domain you like. Full access to this thing is on the Inca RDA and Glade, but you can download it. It's free to the public through the RDA. So in this part of the tutorial, we're going to be logging into Casper. We're going to be submitting a VNC job. This is going to kick off the VNC server so that Casper can then transfer its desktop to your local computer. We're going to then tunnel a special tunnel command into Casper for security reasons. I think like 10 years ago it was being hacked, so we need the security precaution by setting up a private tunnel from our computer onto Casper. And then we launch our desktop with Turbo VNC. So step 1, you have to log into Casper. I'm going to do that through my console. And this will just be SSH of your username at casper.ucar.edu. You'll get a legal disclaimer and then have to enter your password. And there you should get a push from Duo.
So on Windows, would this be like your command line, or what would this, sorry?
Yeah, dude.
Or would it be like, I've got MOBA?
PowerShell, I use MSys2 for a console.
Or PowerShell would work, or?
I use VS Code.
VS Code. PowerShell should have SSH baked into it, I would hope. There's also the Windows subsystem for Linux. If you have that installed. So that should let you do SSH through bash. But then Duo will serve you a push. And I'll wait a minute, but I'm just going to set my push.
Yeah, I think it also reminds me to, I think we should update the instructions for Windows.
Yeah. Something about Windows. So, can I get a showing of hands of everybody who has successfully logged into Casper? Great. So that's part 1, just logging in. Part 2.
10:25 a.m.
Slide.
10.
I'm using slide.
Slide number
Looks
9.
looks like slide 9 has step 2 on it.
Yeah, thank you. All these last minute changes come back to bite me. Okay.
And Ian online has mentioned that PowerShell works fine, it comes with Windows.
PowerShell works fine for SSH, it sounds like. Windows comes with so many shells. Command prompt, administrator command prompt, PowerShell. But PowerShell sounds like the go-to. So I'm here. There is a file in your data directory called bncmanager.txt. This is what submits, what's in this file will submit the job onto Casper. So if I go into my data directory, let's clean this up a little bit. Data, April workshop. Then in Turbo VNC, bncmanager.txt will give you your incantation for launching this job. So you can open that file. Yes, Carl?
Where's that data directory?
So the data directory is the zip file that you downloaded, maybe in your downloads folder. It's called April 2025 Workshop.
Right.
And then in the Turbo VNC directory,
Turbo VNC, okay.
you'll find the VNC installers, which work for some, but apparently not everyone, along with the organization.
VNC manager.text.
Right.
Okay, I see it. Thank you.
I'm just going to copy that and paste it. But what you guys will need to change, there's one field, if I open up my slides again, it's your project code. So right here under your account, this is my project code. You guys should all have one for using your compute hours on Derecho or Casper. That is right here on my window. Again, MEST0001 is mine. I'll have to change that to yours. Issue that command. And this is where the fun begins. We've reserved all the L40 nodes for this workshop. Casper has all sorts of different nodes. The L40 are pretty heavy hitters in terms of graphics memory. I think somewhere around 400 gigabytes of graphics memory per node, so we shouldn't run into graphics memory conflicts. If you do find that you do have a graphics memory conflict on Casper, you may want to direct to an L40 node, because sometimes other users are using graphics applications. Vapor can't get enough memory, and it will throw an error in performance rendering.
But so do I need to change my account key to my own?
Yes.
But that's,
I don't know if it helps anyone. I had to change from my default shell to SH instead of TSH. TCSH.
It wouldn't, on Casper, it wouldn't.
Yeah, just you can't say like X equals true with my default shell.
Yeah, mine says command not found.
Right, mine is too.
Okay,
So I just did the SH and then redid it.
Yeah, try using the Bourne shell. Just type SH, and that should bring you into the Bourne shell. So in your console, gosh, if I was not waiting for my job to start right here, I would just type SH and enter. And so if you're on Casper, does that make sense, Maria?
Yep, that worked.
Did that work for you, Maria?
for me it worked, yeah, I didn't need to change anything.
Danger.
The sheet.
Okay. So everyone has submitted their VNC Manager job, I think, successfully. And you can see Casper is doing its allocation. Slow dispatch times, this is what I was worried about. It's break time. So let's go do that, and when we come back, hopefully everyone will have a VNC job that they can tunnel into. We'll get to that then.
Should I kill it or leave it?
No.
Just let it go.
Stay in line. I think there are 32 people trying to do.
Yeah, we have 6 nodes, and we should be equally distributed amongst the 32.
Yeah.
Jeopardy thing.
I think the shell issue is because of what's set in your SAM account, right? The default, isn't the default the KSH now?
That sounds like it.
Yeah,
There's all sorts of things that can make things go haywire. I mean, usually the 2 biggest things are your profile. I don't use a SAM accounts, but I'm pretty sure the same account is adjusting your profile. So if I were to log in, I'll show you guys what I mean. So my default shell is bash, and if I look at my bash profile, I've commented everything out, but sometimes you can have all sorts of commands that modify your environment, change your shell, and just do things that would happen if you don't specifically remember that's something that you did. Conda is a good example of that. If you install Conda, Conda will just take over your environment, which can be good or bad depending on if you remember what's going on. The other thing is, what is it? Module list. The in-car environment is constantly changing. Recently, they upgraded to 24.12, but that also causes some big changes to the shell environment that we're in.
Mine still says
Consider quitting. Never! Hardly ever get suggestions like that.
Today at work, what happened? I told me to consider quitting.
Consider quitting.
This is an email that I saw. This is a reservation number, not an account key. I don't see anything about getting a specific account key for this. Account. So, reservation number. To the project. If you're ready to go by tomorrow. What's the project code though?
good because we are ahead of time from the schedule, so.
Yeah.
Do you need water or something?
No, I got some. Sorry, I missed your text.
Yeah, no worries.
I can read her on the way down if you want
That would be,
to chat with Mia right now.
Is it data access.hpc.uk? Is it data access.hpc.uk.edu?
Or you trying to log into campaign?
I'm just trying to. For Casper? Just to grab data from that, yeah.
You could just do SF you could do
It's data access, data dash access.
I think I've done that before, yeah. But you could also just do an SFTP
For
maybe.
data transfers, data access.hpc or just .uk?
Yeah, I can't remember. I'm using Windows.
ucar.edu, just, yeah, data dash access.ucar.edu.
Okay. Thanks.
to show up in that shot.
Sounds good.
Oh my god, compiled. Or further mode. Doesn't mean it's working.
Doesn't mean it's running, but it's compiled.
It's a,
Step one.
yeah. Checkpoint.
Yes. You gotta bookmark it. See, that's where I was thinking too, when I compiled 461 on LXD2. And now, oh no.
Yeah. No, it's just locally so far. Once you convert it, then I can squash everything in one commit.
Well, what I want to do is follow. I think what I want to do is I want to try to see if I can repeat the process. One seal. So let's think. No.
Yeah, do you want to make some? Yeah, to see the blocking, yeah, I actually wanted to do that
No,
for
that's.
the Lemhi project,
I can reverse it.
never had the chance to get that.
Didn't you run a test case of the Wasatch?
I did, the land surface configuration is also,
Oh, yeah, still. You have output somewhere that we can maybe try and then put it, even though the generator didn't exist, wherever generators. Let me see what happens. One for the project, because LP is not fully. It's different, but still. Especially in shared environments.
also update that animation.
I know that. Sarah mentioned that yesterday.
Yeah.
So you don't know the decimal points. When I put it in, I made the land surface show up. So I almost have to go here. Every time. This is how you do it.
Dash Q?
Yeah.
Somebody, oh, that's,
I was just reading what was up there.
oh, yeah. I was like,
Yeah, and that's being broadcasted to weather.
yeah, yes, it is. Well, so if I go back to my, I'm not gonna wait for that to refresh. It seems the magic trick is dash Q, R467,
Oh.
5663.
So we should consider quitting.
Yeah, You should quit.
You'll need to change your account to have a better.
That's right, my account, that didn't work last time, this time. See if that does it.
So we were waiting in the queue that was reserved for us.
Yeah.
Okay.
Scott, if this works, could you copy that in one of the slides?
One of the slides.
The slides that I showed, because I think they'll need it for the devices.
The slides that I'm showing are gonna be different than the ones from the PowerPoint here. Oops.
Whenever you guys are ready. Oh, we need to be in a different queue.
Is it
Do we have a specific queue that's change?
until somebody tells me? Is there an updated command?
There is.
Okay.
I guess we have to specify the reservation that we've been getting. So, let me go full screen here. Okay, so next to the, oh, no. Highlight. Next to dash J, there's a new argument called dash Q, and then reservation number. And let me put this in the chat. So that,
I still got the slow dispatch time.
yeah, Mia is saying that they may need to remove the reservation and refresh it. So let's wait on that. In the meantime, let me throw this into the chat.
Not even letting me change.
Yeah. I think that's why Mia may be refreshing the reservation.
I didn't get it in time. Could you just paste that in again?
Yep.
Sorry about that.
Whoops. Wrong chat. And then that should be it.
Got it.
Rebecca, do you have the?
Job has finished
Job has finished?
unexpectedly.
Unexpectedly.
Is anyone getting onto the L40 queues?
Yeah.
I can't.
Okay.
I see, because I see jobs queued onto the queue, but I don't see anybody.
I was trying to kill my request to
Do that.
Yeah, I was trying to over here as well.
And it just keeps telling me you should consider quitting, like I did. And
then
it tells me to consider again.
Well, what I tried to do is create a new SSH.
6, okay.
But
6.
that other SSH worked. So if you can open up a new SSH session, try it there.
Yeah.
And the quitting should eventually work on the previous one, I think.
Yeah, we'll clear things.
So we now see 6 are running, so I think it's working now.
Okay, yeah, I am in, under queue.
New session.
If it doesn't tell you to quit and you get in, you'll see a big screen like this. That's where we hopefully will all be.
What? It's selling unknown queue.
Unknown-
Can we type something?
Unknown queue. Unknown queue.
I'm gonna just copy the command from here to make sure that I can.
So unknown Q would relate to this parameter that we put in.
I should get those numbers right, because that's the reservation ID, and that'll point to the, what's known as the L40 queue, which is the GPU nodes you're trying to get onto.
I accidentally got it
You got it?
with the original line
Oh,
Oh,
on a new session.
without the dash Q R.
Oh, because
Well,
they
I didn't
removed.
mean to, so I pasted it and I was gonna change the key, the project, and it just went ahead and
it was probably when he removed the reservation, right?
So you might have slipped down.
During the reset.
Yeah. that could
Cause
be.
I accidentally, so I'm on whatever that exact line says.
So,
This exact line has been updated?
No, with that account. So I was gonna go in, copy paste it, change the account, and do that. And it just, whenever I pasted it, it went in and gave me that big screen that you showed. With
On,
The
With their account.
NBST 001.
With the NBST 001. I was gonna change that, but it just automatically, whenever I pasted it. It didn't let me change it.
maybe that's a hint. Because it worked for you, it's working for me. You did include the dash Q.
I did not.
You did
I just copied the default line that you originally gave us.
If you don't include the dash queue, it'll default into like the kind of production queue, to count against like your hours or like your normal count usage.
But it's on that project code, the NVST.
Right, well, like it'll still do that, but like it won't get routed into like the reserved nodes, it'll just go to the general pool nodes.
Okay, so I need to.
But he's using other people's hours.
Yeah, I haven't done anything. I should.
Well, like it's so long as you're still using the account MVST001 and you're authorizing that account, you use those hours. But like you'll just use hours outside of the reservation pool.
Okay.
The reservation, it just points you to nodes that were already set aside for this workshop.
But he's in REL.
Yeah.
He's not on our account key.
Well, then you shouldn't even be able to use that account key.
That's what we're saying.
But I did.
Yeah, I can.
I didn't mean to.
It's from inside the valid account.
Yeah, I didn't mean to. I pasted it and I was gonna edit it, but it just, right after I pasted it did it.
So,
Okay, so I get that.
No.
there's a comment online.
I mean, like,
Yeah, because I shouldn't be able to.
yeah, there is a comment
I just
online.
pasted it.
Comments on it?
Apparently they're assigned
Yeah,
to
what was
use
the
account NCI.
The other one was whenever I was trying to
0012,
get out of, and I was gonna do the edits, because the other one I
What
had.
And
was
the original
job
line
here?
without
Give you a job ID
minus
that
Q worked for me with my specific
Right,
account.
oh, it said it was canceling job ID,
Okay.
but then it just wouldn't let me.
Can you control C there?
Oh,
Yeah, same thing, sure.
Oh,
And it won't.
well, no, sorry, not command C, but I mean like copy the ID numbers and
That's
then
what it
like,
sounds like.
so like,
But that's not
yeah,
what
and then,
they were trying to do.
just on the other session, terminal session.
Okay, I think it's working
Q-
with
Q stat dash
with that count
F
somebody suggested on the
dash
chat, NCIS 0012 worked without the Q.
It's me.
Okay,
It took a minute
It says it's
though.
running. and
It
then
took a
also,
little while.
so let's,
Under which you'll see the account center is actually using your account, the SE.
Yeah, this one is, but whenever I open a new window, and I pasted that command, it's, put this in.
Right, that's the output to get you to tell you how to get to the PNC session and stuff.
Okay.
So
then I can use this one, even though I've been trying to kill it.
Yeah.
Like it's
guys,
so-
if you're stuck, apparently this is working. You can try that.
So I don't know how this one is working, but I've been trying to kill it.
What was that?
Don't kill it.
Oh, well, not.
Yeah, keep it.
Working, don't break it.
Oh, that's,
if it's a running job, you're probably fine, and then you can just connect to it, to the PNC manager instructions that popped
Okay.
out earlier or afterwards. And you can like verify like running job status with that qstat command -f. And if you wanna like look at the actual like full queue status, you can do qstat -QF and L40 for the queue game. And as I said, I saw some people running already in it, so.
So now I just follow this, another terminal.
Yeah, you'll get a big dump like this. It's gonna give you the tunnel command. This is the secure layer that we need, otherwise Casper gets tempted to be hacked.
Sure, yeah.
So we run the tunnel then?
Yeah, you exit out from Casper, so right now you should still be on Casper, like on the screen, I'm still on Casper's login node. You will copy this command.
Okay.
So I'll exit. And then for my local machine, issue that tunnel command.
So I need to disconnect from Casper.
Correct.
Or open a new tab.
Or open a new tab. I just exit because that terminal window is no longer needed.
And-
It really works.
I don't, not to confuse, but if you're logged in on an internal network, or if you if you have your VPN on, you can just type in Turbo VNC. There's in the instructions, and it'll work.
Oh, so we don't need to do this?
You don't need to do that if you're on an internal network or if you're logged in with the.
I think a lot of us work from home, so if we're working from home, we'll need to
Use
tunnel.
VPN.
Local network.
Does it say found the job, attachment to it, it's not the job, okay.
We do have a couple comments in the chat. Someone that tried the NCIS 0012
So-
but got submitting batch job to PBS. Use of invalid account for GPU
So the job
usage
exists,
available
that's good.
accounts.
Right.
Trying to attach to it. And then VNC tunnel overboarding message file.
It's probably referring to that bash VNC manager tunnel L40.
That's nice, that's.
Oh yes, it's okay. And is that copied into your home directory?
Something in the form of.
Hey, Dan,
I'll have to go.
Yeah.
can we get you over here? It sounds like you're already on. Your job is submitted and you're good?
The job is submitted, but whenever I do the SSH command, like the second step,
It goes away.
so you exit and then you do it on your local machine, the SSH. It's telling me that the VNC manager tunnel dash L40, no such file or directory.
I think it's missing this last command it's trying to run, but what's in that home dash home slash dot VNC manager slash L40 tunnel file? Is that like something you created?
That's what I use to log into
There needs to
Casper.
be a scanning.
Right, but like, not all the users here will have that same file.
Feature request.
The file you're referring to is just.
I'm trying to plot.
So like,
It's the last part of the command, or not
That's
that
chemical
one.
speed.
It's like down there.
yeah, there's a parentheses bash and then the tilde slash dash.
The VNC MGR slash tunnel.
Basically,
Oh,
10 to the
okay.
minus 7,
Okay.
right?
Yeah, I don't know off the top of my head.
Here, and
You don't
there's
have
no
that
decimal
file?
points for me to
No.
actually specify
On
that
the-
in
on your
here. So
home
if I do
directory in
this, and
Casper?
make it 100 ppb, I can make it show
I
up.
can't recall if that's created or not automatically during the VNC manager process.
Save the number of zeros.
Perhaps it is, but like, I think,
This
I'll
one.
go back into.
if anything, I think your session still exists, but you so you can just like open a VNC session and they'll
There's
start
no
it.
feature request. You've already considered that.
No, it shows that it's not very visible, so.
Yes, okay.
Uh,
Excellent. Okay, now I have to work on opacity though, so that's.
On the server would just be the.
Yeah, and
Okay.
unfortunately, we need to do it.
Use the port numbers that you've
That's
created
something
when
to
you.
globally change that setting.
Mhm.
This.
Yeah, okay,
The whole thing?
globally change that.
Like it usually copies out like the.
Yeah. When you tunnel, or when you don't tunnel into Casper.
Yeah.
you use Turbo
It's
VNC.
like you usually get an output that has like localhost colon
When you don't, you're saying you don't have to tunnel on the local network?
That's what you type into
Where do you
VNC.
tunnel for the VNC server?
So you need to type in, could you show me
Like,
the message that you get?
Yeah, one-time password is being given, it's the wrong one, but.
No. Yeah, over here, it gives you a full path, like Casper dot something slash and the host. So instead of localhost, you get a longer message.
Obviously something's wrong with that.
So I got Tiger VNC running here.
You do? Your
Yes.
desktop?
I see trash at home, I forget what I'm supposed to do
Yeah,
next.
that sounds like it.
So, it's the first time you're doing
Yeah.
VNC, right?
Yeah, so.
Is anybody else the first time they're doing the VNC thing?
Okay.
And you had your folder
Yeah,
on
there's a few
password?
things we gotta do.
Did you make it work?
I did run the little.
I think
other
that's, I don't
tutorial at this
know,
point.
I think that's working.
Oh, you mean the sample
Go
files?
to, click on your
The
application launcher in the lower
.VNC
left.
manager file that's
Right here?
supposed to be on Casper
Mhm.
in a home directory, I wonder if you have to do, like, if it's the first time the person's doing it, do
Oh.
they have to do
System
something
and
else
that setting?
before?
Oh,
I don't think so, because,
system?
yeah, I remember when we did it the first time, it's there and
Sometimes like, you don't
everything.
have to key it, like,
So I think
systems,
if
if
you
you the
send-
session,
Yeah,
it's
I
still
But it's in
running.
your home folder,
Basically,
so
what's
it's
doing is
not
creating a
supposed to be
port
there,
on
like,
your home
he
machine that
started
then ports
working
to
here 2
Casper.
months ago.
Do that like,
So
Okay,
he's
you
the
already
computer
got that.
Maybe.
like encrypted
So
tunnel.
then you should say-
Dan would be the right
Thing is, like, we get like 10,000 people trying to like ping from China to get into our system, so hence all this difficulty.
Yeah, I think you're right, Maria, cause I mean, I'm in, but it does say that file, there's no such file or directory. On my
Which one?
Glade bash, it says, you know, Glade, Bonert,
Oh,
no such
okay.
file or directory. But I don't know, I'm kind of in.
What happens if you just type VNCMG?
VNCG.
MG
No, but then,
Like that?
and enter. It sometimes gives.
Everybody else.
well, were you able to get to
Yeah, I
this?
did something like this
Then?
last night, so it
Because
might
then you
have
open
things
VNC
sort
on
of
your computer,
cached or something.
so at some point you should, let's see here, so when I connected here, right, so
Oh,
I
yeah.
typed this thing,
Yeah,
and then he gave me the local host
stuck.
number, and then he gave
Yes.
me a
I was trying to just
password.
go through.
yeah, oh, yes.
But,
So then they gave me this, it's never asked me for the password.
No, it's gonna give you a password.
Right there.
Here, and so then you open VNC server, like on your local computer.
So then I just went to my
Someone makes a manager,
PowerShell,
like,
enter in
it's not
this.
producing the file that
Yeah.
it's supposed to, I
And
think
then
it's
that's where I
automatically created in
went
that
on my
home,
PowerShell, but
that
I've
VNC
never.
But so you probably can just start
That
with your
folder when you run
VNC
the
here
script.
Okay,
now.
start that now,
Yeah.
and use that
When you run
And
the
use
tunnel,
this local
it runs that,
host
the
and then the
password.
password.
Okay.
Like the
Okay.
connection
you're on
machine.
locate console.
But if the DC manager script itself didn't run
You're
appropriately,
going
then it's not.
around here, I'll see if I can help on the chat.
So like you're gonna see a little window like that one.
Oh, that one up there, okay.
Work.
Okay, perfect.
Yeah, I think I see that message for that.
Yeah, that's right.
So for me, it worked, but I think for her, it's gonna work because they still have the local host and the password. So they can just ignore that the file is not there. I think that's
Okay.
probably.
And then are you on internal network?
So I think I bypassed that last night.
StaffNet.
Just say, okay. I don't remember. Sorry.
Excuse me. Yeah,
Did it work?
So it's asking for the server. So I'll hit connect. And then it wants the password.
Disrespect.
So what's your VNC running? What does it say?
It was not like the original thing, it's RVNC.
Okay.
What's up? I'm in, yay!
maybe a quick show of
Just
hands.
ignore the.
What did I have to do? No idea.
Thing not
I'm ignoring
existing.
it. This is the right place I wanna
And this open up,
Yes.
turbo, yeah.
But so then you open the VNC on your
I think
computer. And then what is the?
So the tunnel worked on your left side, it looks like, or I'm sorry, not the tunnel.
Okay, so you got various tabs down at the bottom of here. So you could click back there
So
and.
it's
but I
what
think
it tells you here, like, so once you do the SSH.
Because there's two
This.
options, and the second
It's gonna
option
tell
is
you.
if you're on.
But then you, most of the time.
So
you're
here's the SSH, right, that's the line.
Mhm.
Got it. Yeah, there are two, but it is the internal network method, so this is what. The internal network method. If you were to.
So we can select files off the blade or something, I guess, if there's
And
no.
connect to the following hosted.
404 files. I was just, oh, we're on Glade, look at that.
So if you have internal VNC framework.
Look at some of what's coming.
My job exists attached to it.
And did you
Great.
your VNC
we have at least
Yes,
3
it's like an
ports
application.
online.
Is it the?
Did you generate another one-time password?
I think so.
Where are you?
and then put the Casper thing there. And then they're gonna ask you for a password, which was provided.
Because I'm also on call today in terms of general.
It's just this line isn't working, so she's getting a screen, I don't get any of that.
Right.
Yeah.
Did you put in a
Well,
username?
so like,
There's a password that's right there, yeah.
Did you put in a username though?
Oh, yeah, that's the one.
No,
Yeah,
so
the name's
I
blank.
got this to, yeah, those are my two-factor, so I found the job, attached
Yeah,
to it.
you don't need to do the
That's it. So I'm not actually.
right, and like, but the original job was created with
Yeah, I
right?
noticed that if
Yeah, so it says the job exists, and there's a job
connection drops
To
or
use
if
this
your
one because I've tunneled.
VPN gets disconnected.
Yeah.
Oh, there you go.
Okay, so that's how you do it.
Whenever I
You
do
tunnel
QStat,
first and then
well, whenever I was
you
on Casper, and then
QStat.
Because they're saying yes, because they're saying
Okay,
if
you're on site.
different
We
instructions.
should probably just
I am
try
on
starting
site,
at the
but I
beginning again.
Alright.
Whatever
You
you,
can do-
whatever works.
Well, you can do control C to do that. You do Q delete the original
How are you able to
job,
resolve the
or Q
issues
del,
mentioned
sorry, not speed.
with the file, with the
I
file,
think, no, I know.
file not
Just
being
kidding.
present in your.
Pressure is reversed.
That was him.
This is, look at.
My word.
Okay.
I have to check, well, I can try to, what was I doing? I can turn the map up, yeah, I know, other than when I go back to my home view, then I gotta do that.
Can I get a showing of hands of people who are on the VNC session, who have a desktop? Just about everyone. Thumbs up on the chat. Okay, I think we did it.
Unique shell.
Yeah.
Guys, the first thing,
So here's where.
we'll catch everyone up if you're behind, but the first thing we want to do is, SUSE is the operating system running on Casper. It has this quirky behavior that makes it hard to select files. We have to change that setting if we're going to have any chance of selecting multiple data files to read in. So on this application launcher in the lower left corner,
See, now,
click on
I
that
didn't edit it, so I'm
and search for your
projects,
settings.
quotation.
You can click on System
Where we
Settings.
got to that initial.
And once you have your system settings open, there's this radio button where clicking on a file or a folder, by default, it opens them. We want it to select them, just like every other operating system in the world does. I don't know why they do this. But after that, we'll be able to select multiple files at all. So after that, we go to our Applications menu again, and we're going to look for our terminal. It's called Console with a K. And once you have a console, there is a command that will check to see if you're using a graphics card or if you're defaulting to software rendering on the CPU. We want the graphics card. So if you can type this command, glx info, pipe grep, and then in quotes, renderer \pipe vendor, end quote, and you should see NVIDIA pop up for the graphics card. If you don't see NVIDIA, Vapor is going to be dog slow. Got NVIDIA? Good. What VNC viewer are you using? Turbo VNC?
Yeah.
Tiger, Turbo? Okay, yeah. We know Turbo works. Tiger should work. It's the other VNC viewers that are being used on Windows that I'm curious about.
Where they connected to the VNC, but it's a blank screen, no files or folders.
Is there an application launcher in the lower left corner? I guess I can type this too. What am I talking about?
Well, I can't probably listen.
Yeah, that's true.
It's got Ian responsive.
Okay,
Yeah, Ian did respond.
all right.
So I'm using Turbo VNC on Windows.
Can you try issuing that command, but in front, whoops, no. In front of that command, you try VGL run. So it'll look like that, the lowercase v.
So is this something that I should test every time I go on Casper, or once, or since it works now it's gonna?
It should work the same as long as your submission command, which is up here.
Is that SSH one? Yeah.
No, it's the VNC manager issuing call.
Okay, as long as I have the L40 specification there.
No, as long as you have, well, that as well as -G.
For GPU?
This is for enabling virtual GL, which is what lets you access the graphics card from a remote desktop. Typically, that's not doable, but -G should enable that.
Okay.
If that doesn't do it, you should be able to access the graphics card by launching graphics applications with this VGL run command. So down here, when we launch Vapor, right, when we launch Vapor, by just typing Vapor, you'll do a VGL run Vapor if you're not using graphics. And you'll be able to tell Vapor will be dodgy if it's not using the graphics card. So that's how to get around that issue.
Yeah, I typically only check if I'm having issues, otherwise it just works.
Yeah, the -G is what I've used before, and that seems to work. It sounds like you're still on hardware rendering.
When I try putting VGL run in front of it, it just says could not open display, no protocol specified.
Yeah, so you're on hardware rendering.
Mm-hmm.
You should be fine. It's just
Gosh, we've got two people who
now I guess I will check the settings.
I wonder if. Could you do me a favor and try to relaunch your job? So we'll do a VNC manager list. And that should show you your active job ID and its name.
And did it have that here?
No error.
We'll take that name and do VNC manager. So, and then type that name.
VNC manager.
Yeah, I'm looking at some WorldChem output.
No session found.
They have an ISO surface here. I can't figure out how to get the contour to turn on properly, but.
Go back to your.
So I did what you had suggested. Here's the name.
Let's see where you have to look at.
Go to that.
So I just picked one CDF file, which might have only one time step.
Okay.
I have no idea what the level on chord is.
Oh, job number.
Space kill.
471.
Base L40.
Oh.
Yeah,
Okay.
okay.
So would I hit yes, attempt to reconnect or not?
No, let's try to set up a new VNC tunnel session, VNC session.
So I lost that, yeah.
Well, that's actually, this is your VNC, is this a terminal or is it?
This is a Windows terminal.
Okay.
Or it's, I'm sorry, it is a PuTTY terminal. So maybe that's why I don't have maybe that's why I'm not using the right, or it's not finding the right thing.
Isn't PuTTY the one that has the problem with exporting display or something like that?
Well, the display is not coming through PuTTY or the terminal. The display is coming through the VNC, like Turbo VNC, Tiger VNC, or whatever you're using. So, okay.
Right. This is I opened up an X11 for pulling it through, and I made sure to check the button for enable X11. It's
No, this isn't X11, this is virtual GL, so you have to
Yeah.
use the VNC application, that's why.
Oh, is
the
it trying to
graphics
fight?
card-
Is it trying to fight?
It can't even access the graphics card
Got it.
unless you're using the
Use Windows
VNC.
because it was
Okay.
So Turbo or
ArcGIS.
Tiger.
So should I go back to, that one long?
You have to come up with
Yeah,
a
Strange.
you're
solution
gonna
for
wanna change
that.
job on that,
Mm-hmm.
and then just access it through
It's
Turbo
like-
or Tiger or.
Windows is
sounds
not
like
really
type.
compatible with like the Linux
this-
remote
it's
work,
this command
right?
here
It's not super
that I need again.
straightforward.
right?
That's one of
You
them
know,
that we
like,
tried.
so
It seems to
with
work.
my work.
for
No,
some
it,
people.
it seems to work, it worked for me.
Like
Okay.
I jump on
So I can try
quite
that,
a
but this is
bit
what you want me
do
to run again, right?
whatever I need to do there.
Okay,
If I
except
need
I need
to,
to change my account key.
or Jupyter, you know, Hub, I run some things there, I process my data, and then I bring my data to my laptop. If I'm then going to do more visualization.
And I had this
of it,
happen once
or
too.
getting it out
It was
on the
just telling,
web
it was
for communication, so.
just telling
So
me
I
I
do any of
can't,
my,
just telling me I
use
can't do
Jupyter
this
Hub
basically.
quite
Yeah, they
But
telling
then
me
I
how to
download,
use QSub
like a
properly.
small subset of
It's
the
like,
data
this is
to
just
my
the
machine
command.
to then start working in ArcGIS, so.
It's a pain, you have to begin with the data.
It's not too bad.
Yeah.
You know, maybe
Go back to
it's
here,
all like
'cause
what
when
you're
I
used
read-
to.
when I got it to
run.
I have to transfer like the text.
Straight out of the box, well,
Can you
so-
try one of the other
See, yeah,
commands if
see,
you go
that's
to
why I love
chat?
Jupyter Hub, 'cause it's just like right click, upload, right click, upload.
Well, there
you
was-
know? I'm like, okay. But like I just have everything
Oh,
open at the same
let's see, here
time,
we go.
right? So,
Oh,
and
This one?
really, it's like it's like process data, boom, I'm there, it's video, great, I got my few data sets, transfer them over, and then I'm just fully here, right, to do it here.
Right.
I don't know if this one will work, and this is the
But I
key we all
would
have access
say
to, right?
75% of my time
Yes,
is
yeah,
on
yes.
the Windows side.
Oh, okay, this,
Kinda.
somebody said that one works.
So it should kick you out.
It'll kick me out if it's not the right account key.
Right.
And then I'll go to another account key. So I had mobile extern started, so that was the UI.
Yeah,
So I
like,
was using,
their
now the
GIS
other
is
thing
never
is,
gonna
when I
be
start with
just
PuTTY, I
like
have to
that.
specify, try to do excellent forwarding. So it's
They
similar
are
to doing
moving
SSH
towards,
dash
like,
Y.
A lot of things are online.
For
you're not
display
Like,
forwarding.
You're not doing
cloud-based
exporting.
stuff.
So I should just start, I need to start a
So,
PuTTY
you
terminal, maybe,
Once I,
not do that.
once I do
Because
like process all the data.
We're just trying
this
like,
one
I'm
first.
building
Let's try to launch the
dashboards,
job
right?
on
So
Casper, because this is what we
highlight
did in the PuTTY
my
section.
See the job is at.
I have those just to
And then after
like,
it connects, it just runs that small dash command to like give you this like detailed information to. Like it's supposed to be
No,
like,
it's not gonna work.
but like, I mean, feasibly, you could just change it to a different number and see if it would work.
yeah.
Yeah.
Cause at least the nice thing is Python's transfer.
Can we consider quitting?
So, yeah, that's really nice. That's why.
This person uses mathematics, this other person uses ID,
Yeah.
this other person uses something else.
So I can go back and put my, I can go back and put my thing here, but I don't think that was the
Game
problem.
changer.
Because it's waiting for a job to start, that means it's giving me permission to use that key.
Right, I don't
Thank
think
you.
that's the problem either. Do you think you could help out here?
Yeah.
I'm going to probably
Next tab.
continue on, sorry, man, but.
That's fine, go for it,
we
yeah,
can-
you don't
we
want,
can-
I don't wanna hold the whole group up, so go for it.
Yeah.
Well, what I'm trying to do is make this pretty launch.
Question, Carl?
Yeah, I'm trying to show a contour here and I get a blank, so I'd like to show some colors.
But I had that up,
My
so it
ISO
wasn't
surface
on
is
the
working,
video part.
or Q vapor.
Wasn't there.
I have an ISO surface,
Basically what I
but
looked
I
at,
show it as a
the video is not
contour
here.
too, so.
Yeah, the one
But I had mobile extern open, and so Scott
Yeah,
was
so
saying.
like, you kind of didn't create that.
Shooting?
On my local
machine, it didn't
So, yeah, and so my contour is also Q vapor.
I gotta reconnect, I killed the job.
Okay.
I gotta try to rerun this.
Yeah.
Which one?
Try it again.
This one here. Okay.
You know, when I'm on Windows, like, I don't know if it would work for you, but I did use the PowerShell, like, once I got that thing. And then I was able to run my
So.
Using PowerShell.
Mm-hmm.
Because it could be an issue with the terminal program that I'm using for some reason.
Yeah, like I used MOBA so originally to get that first command, but then I went to PowerShell to type in that command. And ever since then, it's been okay. So I don't know if that would help.
I can try, I don't think I have PowerShell installed though. Oh, I do.
Yeah.
Let's just come,
Thanks, Jennifer.
Yeah,
Yeah.
yeah, see if that works.
That's what it,
give this a whirl. I'll try
last
it.
century,
Yeah.
which was a
Let me know if it.
like it's from the 70s.
Yeah, I used it. Yeah, I know. Totally. I used this, the MOBA.
I've done some WorkCam stuff and I'm trying to find I'm trying to show a contour. I can show an ISO surface well enough.
But I
So there I have stuff, but if I show a contour,
Okay, can I get a show of hands of everyone who's on Casper who has Vapor open?
Yeah.
Everyone's got vapor
Do you need
open,
for a
pretty
contour?
much.
Okay.
Cool. So,
Oh, okay.
open up my
There we go.
content.
Scott,
Yes.
wait, we have a user online who's still struggling.
So if I have a 3D, can I pick this?
We got a couple of people in here out of trouble as well.
Height of that?
If you have,
Yeah, it's an issue that I haven't seen before.
you should be able to do it.
So I'm following the instructions here.
Okay, I'll follow the instructions too.
Module
I clicked on whether to.
Got it.
Gosh, what is going on here? I think we might have to defer some of these questions until after the session, maybe during lunch or later on. We'll try to get you through everything during lunch. I'm going to go through with the CONUS 404, so if you could watch that, we'll try to get you up and running afterwards. So I'm going to pretend like everyone has a working VNC session and has Vapor. So in my console, whoops, make it bigger and clear this out. I'm going to open Vapor by doing a module, load Vapor, module, load Vapor, and then just launch Vapor. Okay, so for CONUS 404, this data set, let's see, I'll do my split screen again. All right, we're going to start off by loading our data into Vapor. That data is located in a directory called Glade Work Pierce. That's my work directory. And then we're going to find a 2025 April workshop directory that contains the data. So this is WRF data. I'll select my files by going to Glade Work Pierce April workshop, or April 2025 workshop. And then inside this workshop directory is a directory called CONUS 404. This has a symbolic link to the data archive on the RDA. We're going to double click on that data archive. And we're going to be looking at Hurricane Harvey in this one. You know, it's 40 years of data, so pick an event. Harvey was, I believe, on the 26th, made landfall in Houston. So I'm going to scroll down, and I'm going to select my first 3D file. CONUS comes in two sets of files. There's two-dimensional data files, three-dimensional data files. And we're going to pick first our 3D one at time step 0. That's the 25th. I'm going for the 26th, right there. Now, I think I mentioned earlier, Vapor can support multiple data sets. So if you have like a particle simulation for one data set and Eulerian for another, you can load those in simultaneously and render them together. So in this case, I'm going to import another data set. This is going to contain the 2D variables. So back to my import tab, WRF ARW, and then I'm going to select the corresponding time step, just two-dimensional. So I'll scroll down to the 26th at 0, hours. And open that. I will open it as a new data set. So there's those two steps, opening the 2D data set, 3D data set, and we can see in our renderers panel now, we can click on the 3D data set, look at the metadata, translate it, scale it, etc. That's for the 2D data set, and we can do the same things for the 3D. The 2D and the 3D data sets have different extents. So the first thing we want to do, I believe, is stretch or translate and stretch the two-dimensional data set so it aligns with the 3D data set because they have different dimensions. So I'm going to click on my 2D data set. I'm going to translate it on the z-axis by -6,000. Whoops. And then scale the z-axis by a factor of 50. Okay, good. Now from the 2D data set being highlighted, I create a new renderer with the plus icon. We're going to start with an image. Double click that. And go ahead and enable it. And there we have our first image of CONUS. In the Appearance tab, we are going to do a few things to change this image. We're going to do some different map imagery in this one. We're not going to use the geotiff files, or not this geotiff file. we're going to select a file that's in that same directory that I mentioned earlier. That is Glade Work Pierce April 2025 workshop, CONUS 404. In this directory is a geotiff called State Borders. I'm going to open that. You can see it's kind of hard to see on the screen right now because we're not so zoomed in, but now we're just seeing the borders of all the different states. In the Appearance tab, I'm also going to click Draw Renderer in Front. So this will draw the states in front of the renderer, kind of like what you see. I think I have a slide that shows GOES imagery, maybe not. But if you ever look at GOES imagery, they always superimpose state borders because you're looking at a landmass and it gives orientation to draw the borders on top. The next thing we'll do is instead of an image renderer for our topography, we're going to create a contour renderer for our topography. So in the same data set, I'll click plus, make sure that the data source is the WRF 2D data set up here. You can create new renderers for either data set. We want to always target the one that we want to render. And I'll double click contour. From the contour renderer being highlighted, we go to our variables tab, and contours like barbs can be 2-dimensional, 3-dimensional. We'll select 2D and select our height variable, which is named Z in this data set. And then we will apply Z to itself. So we're selecting Z as our variable to render, but we are applying itself to a height offset for that renderer. And then we can turn it on. And we should see something like that, Carl. I'm curious. Okay, so something's going on with that other 3D variable. In the Appearance tab for the contour renderer, what we're going to do is load a highlighting color map. So go to the Settings menu, load built-in color map under Highlighting, and just a precaution, guys. On these VNC sessions, this frame buffer doesn't always update. So you're going to see artifacts from a previous frame buffer in the current frame buffer. You have to refresh it. Like you can see, right now, okay, so I have all this text, like file dialogues will persist in this frame buffer until I change the scene and force it and update. So when I click on the Settings menu, this menu is going to persist. I'm going to sneak in and get there. Okay, so I didn't open up any other of the color bars. They're not going to persist. I'm going to click on this topo color map. So then we change the topography. We're going to change the number of contours that we have. We've already enabled it. We're going to change the contour spacing to 80 meters. And that's going to squeeze all these contours down to the base. And then we're going to crank up the count to the maximum value of 50. And so now we have kind of the mountainous terrain being highlighted offset by height. Along with the state borders at the very edge. All right, so for our 3D data set, we're going to highlight that and play with isosurfaces. Isosurfaces are three-dimensional contours, just a surface at one value of variable that we pick. So press the plus icon, make sure we are selecting the 3D data set, double-click isosurface, and we go ahead and enable it. And let's see, looks like our default variable is cloud fraction, and we're going to keep that as is. You can change it if you like, but for this example, we'll be using cloud fraction. Now in the Appearance tab, contours and isosurface values are selected through this widget down here. You can see my data value is 0.5. I can drag it, and Vapor will render it in fast mode. Doesn't seem like there's too much of a change until I go to the very bottom. You can see how the variable changes as I slide back and forth. I'm going to keep 0.5, I believe. And in this case, there is an issue on SUSE where this panel might be cut off. So you can expand the left panel by clicking on this middle bar right here and dragging it open. And now, there's my visualizer. It's very tiny, but at least I have access to all my controls. Okay, so the ISO value controller, we already set that to 0.5. And now let's take one of the opacity control points and let's apply some transparency to our ISO surface. So we can drag this down, and you can see I can make my ISO surface vanish at that point, or bring it up. And I think we're going to set it to an opacity value of 0.7. So it's a somewhat transparent ISO surface, similar to a volume renderer, but just at one value. I'm now going to check this box down here, scroll down a little bit past the transfer function. I can color my ISO surface by another variable so that that surface is colored according to a secondary variable. You have a surface at one variable colored by an arbitrary variable of your choosing. I'll click this box. We see another transfer function. So now we have two. Up here at top, we have our ISO value selector that controls its opacity. Down here, we have our color map transfer function that's applying the color to the ISO surface. The color map variable by default is cloud fraction. So that's why we're only seeing one color. There is only one value on this ISO surface. It's not going to have different hues. So instead of cloud fraction, we're going to pick 10 centimeter reflectivity. And now we have our ISO surface. It's so hard to see, but colored by the reflectivity. Going to make some adjustments to the transfer function. I think we are loading a built-in color map, the sequential one named algae. So click the gear icon, load built-in color map. There's that frame buffer artifact, sequential, and algae. Okay, so we have a somewhat transparent ISO surface renderer. Next, we're going to create a volume renderer and compare the two and see how they contrast with each other. So from within my 3D data set, I'm going to create a new renderer, double-click volume, and I'm going to disable my ISO surface renderer because if I have too many of these things going on, it just becomes too busy. You can't tell one thing from another. So disable ISO surface, keep the volume. It's maxed out in opacity. And we are also going to render cloud fraction in our volume colored by reflectivity. You can also color a volume renderer according to another variable. So apply a transparency through the volume with different values being different opacities, and then color it differently as well. So in my volume renderer, I go to my variables tab. Cloud fraction is our target variable. Our color map variable is reflectivity. I believe these controls are repeated down here. If I click on color by another variable, or maybe they're not repeated. So we have to pick our color map variable in the variables tab. Once we have that, we can play with our transfer functions. So we're going to ramp the opacity of the volume renderer from 0.1 to 1. So I believed I deleted 2 color control points. We're only going to be working with 2. So double click 2 of these. Take this guy, bring him down, and give it a data value of 0.1. And this value should be maxed out at 1, so maximum opacity at data value 1 for the volume. We're going to go down to the color map transfer function and also load algae like we did with the ISO surface renderer. So scroll down to the color map, click the gear icon, built-in color map, sequential, and that is algae. Yeah, oh no, that's deep. That's algae. Interesting. Doesn't look as opaque as I thought it was. But I'll debug that now. Yeah, we should be seeing, oh, we're applying more transparency. So the volume renderer has a global transparency setting you can apply, and that's often useful. So we're seeing, this ramp between 0.1 and 1, and then we can apply a global opacity of 0.3 with the volume density slider or the numeric input. So I'll put 0.3 there. Now we have a global opacity applied to every variable, or every value of the variable, also being ramped according to the opacity color map, or the opacity transfer function that we have up here. At this point, you have an isosurface and a volume, and you can compare them side by side. You can render isosurfaces and volume rendering simultaneously. You cannot render more than one volume renderer at the same time. The ray casting algorithm that Vapor uses, we're basically firing a laser through every single pixel perpendicular to the viewpoint and then sampling the volume, accumulating a value until we hit a maximum opacity value or we exit the scene. And that algorithm does not intermingle multiple volume renderers. So volume renderers are kind of a singleton that way. But you can do volumes and isosurfaces for multiple 3D variables. I think Lee was doing that in the example video of the tornado that we saw earlier. Okay, one more renderer to go through. Oftentimes people have like wind turbines or cities, model files of objects that they want to bring into Vapor to show turbulence off a wind turbine, or if they're doing urban LES, they want to see how the winds are blowing around a building. We do that with the model renderer. So what I'm going to do is instantiate a new renderer, select model, and the model renderer has not as many controls as the other ones. Basically, you select the model file from your computer. I'm going to navigate to my work directory. Again, that's the CONUS 404 directory in April 2025 workshop. And I have a model file for this thing called Benchy. In the 3D printing world, there's this benchmark print called Benchy. It's a little boat. If you can print a Benchy, then your printer is calibrated. It's probably the most famous model that I know of. We're going to double click on the Benchy STL file. And the hardest part about the model renderer is that these model files have their own coordinate systems that are usually in millimeters. This CONUS 404 is in kilometers. It's massive compared to our Benchy. So we have to translate and scale it to position it and make it even visible in the first place. So the values that I found worked best for this for scaling are 5,000 on X, 5,000 on Y. So I'm going to scale Benchy by 5,000 on X, 5,000 on Y, and then we should see Benchy, Z also by 100. Oh, I got these mixed up. 100 on Z, 5,000 on X, and then 5,000 on Y should be correct. It's disabled. Thank you. Oh, 100 on Z. Let's try. Yeah, Benchy is a little too scaled on Z. Yeah, maybe 20? No. Try 1. Oh, okay, looks like Benchy is reasonable. I don't know, that's still too tall. I'm going to go by 0.5. Okay, that 0.5 seems like the correct value for our Benchy. So now it's positioned outside of our domain. We're going to put it in the eye of Hurricane Harvey next. And for that, we will translate on the X and Y axes. So my X translation, I think, is 100,000. Oops. Right? Yeah, something different. Oh, man. I even have my commas messed up. First pass. Let's try 3,500,000 meters on the Y. Okay, close enough into the eye of the hurricane. Looks like he's sitting on Houston. If you wanted to lift him up into the hurricane, you can then also translate on Z, or basically just position the model. So, okay, I'm just going to leave that as 0. But basically, you just have to finesse this until your model is in the right location according to the turbulence and vorticity that you're looking at. This is an STL file. We use the ASIMP library for this, which can read different types. I think 3MF, STL, I'm not sure about Collada, but it's a pretty universally used model reader. So we should be able to work with that if you have it. There's all sorts of models out there. If you just look up NOAA STL files, you can find satellites, wind turbines, buoys, all sorts of sensors, turbines, and all that stuff. So those are my slides. I guess that went kind of fast. I guess the last thing to talk about real quick, FFmpeg, is the tool that I use to make my videos. You can use QuickTime, DaVinci Resolve. There's all sorts of ways to do this. I like FFmpeg because it's kind of everywhere. It's already on Casper. So I'm going to show you how an FFmpeg command works by first increasing this. There we go. I'm going to CD into Glade, Work, Pierce, 2025, or is it April, and then Conus. In this directory, I have an images folder where I've already captured a time series. Actually, no, this is something Matt put together. He did a Katrina, a time series video of Katrina using this data set. It's just, the data set's too big for a workshop. It would take forever to load, and we only loaded one time step. So I'm going to CD into my images directory, CD in Katrina, and then the FFmpeg command that I typically use goes like this. There should be an FFmpeg file in this directory. I'm going to copy that, paste the command. Oh, okay, it's asking me to overwrite, but I want to go through these parameters real quick. The frame rate is 12. This is going to depend on the time fidelity of your simulation. If you have very high time frequency, you might want to increase or decrease the frame rate depending on what looks good to you. This pattern type is what is defining what FFmpeg is looking for. So right now, we're just looking for everything called a PNG, and it's going to numerically list these guys and ingest them one by one. The codec is libx264 to create an MPEG. The pixel format, YUV420p, we need this to run on QuickTime. QuickTime needs this. If you generate a movie without that command, it won't run on QuickTime. And then finally, the output file name. I'll click yes to overwrite. And then, I don't know, I'm going to skip a step. I think in my downloads directory, I've already SCP'd this file over, I believe. Or no, maybe I haven't. I'll go to my terminal and then quit SCP Pierce at casper.ucar.edu. Glade, work, Pierce, 2025, April, workshop. And then Conus, 404, Katrina. And then Katrina.mp4. Copy that here. What directory am I in? No such final directory. Just do a manual copy and paste. Typo. And then the target directory. Okay, there it is. And let's see if I can just open it. And there we have perspective animation of Katrina coming out of Conus from about 50 time steps at a frame rate of 12. I think that puts us at time. Thank you guys for your patience. That was a few snags we need to think about for the next one, but this is a great first try, I think. So thank you for attending. I think, yeah, I guess 15 minutes for questions before lunch. Yeah, I just mentioned lunch is not provided for this workshop, unfortunately. There's the cafeteria that's open. I think I'm going to drive down to Illegal Pete's to get a burrito. I can take 6 people in my minivan if you want to come. But yeah, we'll open the floor to questions.
So the controls on the VNC manager don't work. Zoom in.
With your trackpad.
Yeah. I can just like drag and move it around, but I'm able to traverse.
Here, can you try the mouse? Yeah, this is why mice are so important, I think.
Do I need to quit?
Yeah, on Windows it seems to work.
Just
So the traverse is to hold the middle mouse button down.
Yeah, the traverse works, but
then
like
the
zoom
zoom is the right mouse button.
and the,
No, and then you drag. So right mouse hold and
okay, then it works, okay.
and then on the mouse to traverse, you click down the middle mouse button.
So far on, but I know it works now, so.
Yeah, that works.
Yeah, mine works.
Yeah, right
Okay.
click zoom often catches people.
That's as far as like, there's no point in like trying to scramble it.
That's cool, I can feel my eyes.
I was able to find the place where the state borders were in the parent directory of the data.
So you've loaded the data, or
I'm just trying to put state borders on.
oh, so let me see. Did you create the image renderer for it? So yeah, you've got the image enabled, and then there's that frame buffer problem. And then under appearance, and then you're going to select your image file.
Oh, okay. Okay.
Those are the defaults that we bundle.
Borders?
Mm-hmm.
Okay.
And then try to refresh that.
How do you refresh?
Just like, you can just wiggle the scene. I don't think the frame buffer updated there. If you just click on the scene and, okay.
Oh, okay, it's there.
And then you might probably want to draw it in front. Where's that option? That is, it should be under appearance.
You did translate before, right? And then that usually helps.
That can do it, but that puts the renderer at a different spatial position. Whereas draw render in front keeps it the same position, just drawn last in the algorithm. But that should be under the appearance tab. I'm surprised. We've got Vapor. This looks like an old version of Vapor. Yeah, this is an old version of Vapor. Did you? Just curious.
It offered to do a new one, and I said no.
Yeah, this is our previous version. So that's why the draw renderer in front. But if you do a module load, which I'm not sure if you're running this from an installer.
It was module load, yeah. Was module load Vapor and then Vapor. Module load Vapor is what I did.
Gosh. I'm not sure why it would do that. I wonder if you're using an old in-car environment. Sometimes, like my in-car environment was.
That's probably it. I was fiddling with that yesterday.
Okay, that's happened to me too. Sometimes it changes, and
for something else. Yeah, I had to go back to 23 something.
yeah, I bet that's it then. Yeah. Yes, about the state borders, you do need to be on version 3.10 to draw on top and use that feature for the image and the barbs and the contours. Hey.
So I try to export again from Casper, it still freezes.
Yep. We've done some major refactoring in this release too on the internals, and that's it's a very old piece of code. Vapor Vapor 3 has been around for 10 years now, and there is some cleanup that we're working on doing to make things, more understandable for ourselves, but it also tends to break things at the same time. Vapor 3, 2015, roughly, I think.
But then, so here, does it do the same thing? Like, does it somewhere that I can open that again?
Yeah, that should be defaulting to your home directory, but you can check in your, let's see, in your preferences, if you go to File, or I think on Linux.
Yeah, there's no preferences on Linux.
Linux puts its preferences in the edit menu, and so this is kind of one of the snags about working on multiple operating systems. They're all a little bit different.
Found it. Thank you.
Any other questions?
Dan, were you guys able to get that session running eventually, or is it still?
On his session, it's still a little wonky, so I can check on it. Yeah.
Okay.
So mine's fine.
It's
I was making a silly mistake.
Well,
I was searching for the NVIDIA on my local machine rather than through the terminal window, through the Turbo VNC terminal window through Casper.
okay, that's a new one.
Yeah, that's it. Yeah,
Well, good.
one for the record books.
Nice.
It's confusing. When I have Tiger VNC open and my own desktop open, I sometimes mistype commands in one terminal to other, so it's actually quite common.
Yeah.
And by the way, folks who are on Windows machines and people who are using x86 Macs, for you folks to follow the the Python API portion of the tutorial, you'll probably need to do the same thing. You'll need Turbo VNC and
Right.
run those things there. So
Yeah,
make sure that you don't close close the session.
Right, leave your session open. We found some problems with, Conda, which we distribute our Python API with on x86 Macs. Is anyone here using an x86 MacBook?
Yes.
Got one.
That's the Intel chip?
Right. Yeah, they moved to ARM a few years ago. And we're considering deprecating x86 support for Mac. It's about 5 years old now. And it's, holding us back, I think, from other things. So I think if it's an in-car computer, you might be up for a refresh soon.
Maybe.
Hopefully.
You can ask online too.
Yeah.
So for the other one,
I can't confirm that will replace your Mac with a M1 or M2 Mac if you have that older one. I still have the older one, but I'm just lazy to take the time to move all my files and things.
Yeah, me too. I don't like changing computers, reconfiguring my environment.
so when we're doing the Conda part, is it gonna be through Casper as well?
You can optionally install it on
Yeah.
the local computer, but
Yeah, if you're on, do you have an M1 Mac?
Yeah.
Then you should be able to locally run it. So we'll provide the notebooks that are required, and if you have the sample files that.
I don't have anything locally. I use Python on Casper. Do you think that can work? Or is it better if I install it?
Jupyter Hub? Or do you use Jupyter
I
Hub?
use through the terminal. I Python through the terminal.
Oh, okay. You should be able to use it. I'll walk you through the steps on. It's similar. We open a Turbo VNC session similar to how you've seen here. And Conda is available, so module load Conda, and you'll be able to open an environment and use from here.
Okay.
If you have something, you can run it locally, yes.
should we show the instructions for installing the Python API to kick that off if people want to do it? Or we're about to head out for lunch, guys.
Yeah, we have, yeah, so are you folks familiar with Conda?
A little bit.
Okay, then how about online? You have the mic. Can you ask them if they have?
There was more.
Share on the.
Yeah, to our viewers online, can we get a thumbs up or a comment in the chat section if you're familiar with Conda, just from our users online?
Okay. Yeah, let's just go through it after lunch, I think. Because if you're on Casper, I've already set up an environment, so let's use that.
So Casper will probably be the way to go. Though you could do it locally.
But yeah, I wouldn't recommend everybody to go on Casper in case we run into similar issues. But yeah, if you have an M1 Mac, or yeah, you should be able to run it locally. Or any Linux. Okay. 310, but yeah, I've updated the instructions to anyway 3.9. Alright, then I think we can adjourn for lunch and we'll be back at the hour. 1 o'clock.
Can I think I have to kill the session, right? Because if I close my notebook.
Does it?
If you're tunneled, it will. If you're not tunneled.
Still has the Casper session. You
Yeah.
just have to start it again and then.
Yeah, you can kill the tunnel, but then
Yeah,
the
and then
allocation
reset
should
up the
still be
tunnel.
going.
So I think it depends if you have a tunnel.
So do I just
Your
close
internal, I
the
think it
sync?
might stay
Is that
open.
what I do?
Yeah, you can close that.
But if you're external
Okay.
and have a
And you
tunnel.
can even kill the.
My tunnel will always break.
Yeah?
When my computer does
I
this.
guess I usually go in, I usually have.
Yeah. Is this window that you requested?
One of those things.
Yeah, that's the window I did the SSH here.
Anyway.
I'm always external.
Just a 5
Yeah, you can just, yeah, I think you need to ask you to terminate the session.
I think it'd be very simple, but.
I mean, if I drag.
So if you close the
ends of
tunnel,
those
that should be
things
fine.
down, like the little circles down, so changed my isosurface transparency one time, actually.
Okay. I don't,
And actually, if
I
you
don't quite understand how this thing works.
And just want to be able to
But
save my session.
yeah, so that's on Casper, right?
so now it suddenly is talking about.
Well, not right
attaching.
now, but this was from Casper.
It is, okay.
Yeah, this is just where you can see if your allocation
Okay,
is still.
so I guess.
Like if your job is still running.
So what I wondered was, so I flipped it.
Okay.
Right.
Yeah.
So this is the
running.
transfer function for a path.
The job is still
It
running.
has
It's running, yeah.
capacity, yeah, that's,
Yeah, you should
Just
speak.
wondered here if I can
Yeah.
transfer.
capacity.
Are you gonna go for lunch?
Do we have one hour? Is it 1 hour? 1 hour?
Yeah, back at 1 o'clock.
This is one I downloaded
I'm
from
gonna
working on
do
some of our
it.
stuff. It just-
Okay, I like it.
All right, welcome back, everyone. Hope you had a good break. We instead of this one. Just check right there on that one. There we go. Oh, is that mine?
Yeah, that's
It
your
is. So
Should be your one.
I think I'll just mirror it.
Yeah, that should be good.
Mirror it.
Right there. Mirror for built-in.
Yes.
I mean, the only extra thing to do you haven't done yet would just be to share your screen in Google Meet too. So we can get that recording for online
Oh,
people.
okay. So should I open Google Meet?
Yeah.
Just join. I probably need to mute.
Yeah, that'd be cool.
And
Yep, got it. I'll click that. Yeah, there you go.
Awesome,
Yeah.
thanks. All right, everyone. I think we will be covering, not I think, we will be covering the Python API now. So if you have the slides with you, you would need the slides for this portion because we have a couple of hyperlinks included. So it's the presentation that says part 5. Awesome, thanks, Sam. And just a heads up, the Python API is not working. We don't have it working on Windows as well as x86 Macs. So if you're on either one of those devices, we recommend using it on Casper. So you follow the steps similar to what Scott has mentioned earlier until you get to the Turbo VNC desktop. So we can take it from there. And quick show of hands, how many folks are familiar with Conda, especially the ones online? Okay, so yeah, we'll be using Conda to maintain or manage our environments, and also we'll install Vapor through Conda. I'll walk you through the process. Okay, so quick recap. The morning session of the tutorial, we've covered how to use the graphical interface for Vapor. Over the past couple of years, we kept getting requests on, like new and important things to add to Vapor, but like given a small team, we've often struggled to, put all of them together. Additionally, one of the commonly requested feature was having a scripting interface for Vapor to extend the capabilities of Vapor. Scott earlier mentioned how, let's say you want to create an animation where you are gradually changing the opacity values of a certain renderer. You can do it manually if you want, but you won't get that precise action by doing it manually. So that's also the reason for having a scripting interface. So a few years back, we released the Python API, 2 years back actually, and then we've been like improving and fixing bugs and stuff related to it. So essentially with the Python API, you are able to do everything that you can do in the GUI, like through scripts. I would recommend using the Python API in tandem with the graphical interface, and I'll walk you through a few workflows on how that works. So there are 3 things that we will need to follow through this portion of the tutorial. First one, that sample data that was shared earlier. That's the same folder that you have from the previous section of the tutorial. Next, we need to install the Vapor Python API through Conda. I'll go through the instructions next. And you'll also need to get a few example notebooks. These are tiny files, and you should be able to download them quickly. Stepping through that process, quick introduction to Conda. Conda is a very popular, it's both a package manager and an environment manager. So let's say you have your workflows, regular workflows, you use certain packages from some of the available Python packages. All of them might have dependencies. And let us say you bring in a new version or a different package that has different versions of the dependencies. Having environments can help you like sterilize. Environments are these sterilized things that you can put your workflow in so that you don't have any dependencies or package conflicts from your other workflows. So Conda allows you to have those environments, and also like you can install different packages from Conda. So things like you can do Conda install and name the package, and you can have it in your workflow. If you're on Casper, you need to type in module load Conda initially for you to be able to use all the Conda functions. If you're not following the tutorial on Casper, you can get Conda by installing it from Mini Conda. I've included the link in the slides, so feel free to do that. So for getting started, quickly,
for this portion of the tutorial, the instructions on the left correspond to if you're using your own computer to do it. On Casper, it's fairly easy. Once you do module load conda, you can activate the environment that I've mentioned here. So this environment already has Vapor installed in it and Jupyter. It has Jupyter, everything that's required to get started with the tutorial. So it's a one command thing for Casper. If you're on your own machine, I'm essentially creating a new environment. My numbers are wrong, but yeah, and then you activate that environment, followed by you're looking to install version 3.9.3 of Vapor. And I've noticed that sometimes Jupyter, it doesn't recognize commands from Jupyter, so you might have to install Jupyter. So online, if you folks are at this step, if you're ready, just give me a thumbs up. And in the room, okay. So that's 2 steps. The third step is downloading the example notebooks. For this portion of the tutorial, I've included them in the Google Drive over here. So go ahead and download that zip file and unzip it. It should have all the example notebooks that we'll use for this portion of the tutorial. And of course, once you do that, change the directory make that your current working directory and launch a Jupyter notebook. While you do that, I'll try to do it on my end. Oh. Sure. Unfortunately, we can't. We've been trying to get it running on Jupyter Hub, but a little longer. We've been having some issues with widgets not working properly in Jupyter Hub, and so yeah, I would say yeah, let's do Turbo VNC version for that reason. But ideally, Jupyter Hub would be the way to go. So down the line, console. So I'll do module load conda activate. Yeah, 2 is wget works, but since it's hosted on Google Drive, the process is slightly different.
But should I have these files locally on Casper?
Yes, please. Yeah, if you visit that link, I think you can, from a browser, you should be able to download it. Yeah, so if you're in Turbo VNC, what I typically do is just copy that link and you should be able to download it to Casper. Yeah. And let's see. Conda activate. Control V. Control Shift V.
These commands were through Turbo VNC, not from our own terminals in Casper.
Yes, we are essentially working on Casper. Let's do conda env list. Okay.
So you open a browser there and
Oh, you can download it. Oh yeah, it's Control V or Control Shift V. I think it's Control V.
All the operating systems are different. Control V for Firefox will paste. If you're in the console, it's Control Shift V.
Paper. V1. Woohoo. So go to downloads.
Yeah, once you're in in that folder, you can do Jupyter Notebook. Yeah, actually, I went. So let me know if you folks are at this step. So once you launch Jupyter, you need to go into the folder that says introduction, and you'll see what I'm seeing. What step 4? Oh. Oh, it doesn't. Are you on Windows or?
Windows, yeah.
Oh, it doesn't work on Windows.
No, I'm
I'm in
Casper, sorry.
Casper. Can you check that? Okay. Did it work? Okay. Oh, Python version. So I think you need to downgrade it to 3.9. Okay. Yeah. How are folks online doing? Okay. Okay. Should I keep moving or? Show of hands, how many folks are at this step? Not yet. It's solving in mind.
Started, but I couldn't even
Oh,
get
shoot.
this to work anymore.
Did you use the same account key before?
Oh, no, I used
Yeah. Try with the NVST account key if that works.
I downloaded the zip file, or what was
Oh,
where
so
does that go?
yeah,
Where do we
you just
put
copy that link,
Uh-huh.
and in Tiger any VNC that you're using,
Got it.
you can open a browser in that desktop, in the remote desktop, Yeah, do you,
Oh, go through
yeah,
Firefox. or something?
Firefox.
Oh, okay.
And then that you can bring.
Got it.
Yeah. So she's having trouble requesting the resource. So for folks who've reached this step, we'll start with the introduction notebook. While we are waiting, I'll do something else on the side.
Browser that opened here for me from Casper.
Mm-hmm.
That's what was.
Yeah, so you're essentially downloading those files to Casper. You can do wget as you've mentioned, Maria. So
No. So I started the Jupyter notebook with
okay.
a command, and then it browser, the Firefox browser from inside Casper.
Yes, that's right. Yeah, at this point, you're essentially using Casper as a remote machine. Yeah. Okay, so I think in the interest of time, let's keep moving forward. So for folks who are working through the process, once you reach the step, you can go through the introduction example 1 and example 2. I have plenty of notes and comments in those notebooks, so you should be able to follow. But if you run into any issues afterwards, just raise your hand or flag and we'll be there to assist. So a quick recap of what we've covered in the morning. Essentially, if you look at any Vapor handles its visualization workflows through something called session files. So that's the bigger box that you see. So within the session files, you have everything. So in a Vapor session, you can load multiple data sets, and each data set can have multiple renderers, and each renderer has its color bar and annotations. And there are some annotations like if you take axis annotations or background colors and things related to the scene, they're applied at a much higher level. So essentially, you need to understand this primarily for the Python API because that's what is needed. We can essentially, if we have to recreate a Vapor workflow within the Python API, you first create a session, then you load different data sets into the session and apply different renderers to the data sets. You annotate the data sets, and then you can export and save your files. So the 4-step workflow that we keep mentioning. So it's importing data, applying renderers, annotating, and export. So today I'll cover 2 example notebooks that will show some sample workflows. But really, the Python API can be used to do a couple of things. So one thing is you can use the graphical interface and the Python API interchangeably. So you can start your workflow with the graphical interface, save the session file. You can open it in the Python API, continue your workflow that way. That's useful for like one example over there is like you can take one time step of a data set that you're interested in visualizing, apply your color bar transfer function and everything, and then later on through the Python API, you can load a much larger data set and apply it on Casper or some other machine to go through all the data sets. You can also create sessions in the Python API, save that session file, and you can open that session file in the GUI and go that way. Batch rendering is something I've mentioned earlier. And the other cool thing is you can also have customized limited interaction notebooks. So let us say you create a visualization, you save the session file. With the Python API, you can expose a little bit of a functionality of Vapor, like you can create a slider to slice through a data set or create a 2D renderer. I'll show you one example of it. And you can share that with your colleagues for, to share your results or for interactive exploration. So in the first example, we'll see a full workflow using just the Python API. The first step is to import all the modules from Vapor and Jupyter widgets. So this part is going to change in the latest version of Vapor. So if you need more information or resources about the Python API, I forgot the slide. Some of you folks might be familiar with the Project Pythia. So Project Pythia has lots of resources related to Python workflows and some of the commonly used Python libraries and tutorials related to those. Be sure to check out the Vapor Python cookbook on Project Pythia. So that should have lots of examples, tutorials, and other material for you to follow. Okay, going back to Tiger VNC. One more thing. In the Jupyter notebook, I would recommend not to run all the cells at the same time, because the way Vapor works is, you can run things cell by cell, but essentially once you create a session, that window, Vapor remembers what's happening in that window. It's preserving a reference to that window, so any changes that you make underneath, it's going to reflect in all the windows. So if you make any change in the previous cell, you would need to run the notebook from the top. So anyway, this part is fairly self-explanatory. We load the modules. And this is the step where we are opening a session and we are opening a data set. In this case, the example that I'm opening is the same one that Scott showed earlier in the morning. It's called, it's the tornado example. In this one, I'm actually using Vapor's inbuilt data reader. You can also load X-rays. You can also bring in X-ray data into Vapor. One caveat over there is that will prevent you from using the GUI. So if you start with the Python workflows, bring in a data through X-ray, you won't be able to bring that into Vapor. But if you use Vapor's inbuilt data readers, that should allow you to move back and forth. But besides that, it's more or less the same. So once you have the data set, you apply renderers. In this step, I'm applying a volume renderer and flow renderer. And let me run the cell. And session.show is used to quickly show what's in the session. So as you can see right now, you can't interact, it's just an image. So it's not very useful. For that reason, we have widgets. And there are a couple of things you can do with widgets. You can have things like sliders and other interactive elements. Or you can also have, you can make the window itself interactive, so that you can now drag and move your data set in the scene. So we brought in applied two renderers, and next adjusting appearance with the transfer function. So this part gets a little tricky in the Python API because this is best done in an interactive way. So this step is similar to what we did before, where we applied a color map, and then we used the opacity opacity curves to adjust the opacity at different values. One thing that I like to do is, like if you were to open Vapor, I'm opening the GUI version of Vapor. And something is weird. Let's just load a quick file. And documents, workshop files. You don't need to replicate this stuff. I'm just showing if you had a Vapor session open. Let's say you, yeah. So once, let us say you've started your workflow with the GUI, and you have the transfer function, and the color map and opacity is set up. You can save the transfer function over here. So this option saves a file that ends with TF3. The advantage of doing that is the color map and opacity. So that transfer function can be directly applied to the renderers to bring in all the parameters instead of you trying to like adjust each value programmatically. And that's exactly what I'm doing. So in your example folder, I've already saved the transfer function that we've used for volume and flow renderer. So we'll just apply those. And that should apply the transfer function. And again, as I've said, each renderer has its own values and parameters that you can adjust. You can learn about each one using the help function. In this step, essentially what I'm trying to do is I'm selecting the renderer type. So that's I'm selecting a streamline. So that basically renders it as a tube. I'm selecting the radius of the tube. I'm enabling the geometry as 3D so that it interacts with the line, with the lighting. I'm setting the color map variable to reflectivity or simulated reflectivity. And rake region is essentially where you're seeding. You're defining the extents of the rake, and you're setting like what's the resolution, how many seeds are you releasing over there. And then we show this. So that should give you the flow renderer. And next step is annotate. So there are two kinds of annotation as I've shown earlier. So you can have annotations or color bars for individual renderers, and you have scene level annotations. So in this cell, I'm essentially setting the lighting and enabling the color bar for the volume renderer. So yeah, it's the lighting applied to it and the color bar, followed by, now this is scene level annotations where I'm changing the background color and enabling the axis annotations. After which, yeah, you can, I'm basically exporting a TIFF file and also saving the session file for later. So now, at this stage, you should see two files in your folder, working directory. One of them is the image, and the other one is the session file. So if you have Vapor open, my file is hidden behind. I'm wondering how I can close the. So there should be a file menu that's hidden behind this. That's weird, right? Yeah, I think, you know what, let's do this. Add panel. Oh, is there a remove panel? Never mind, I don't want to waste. But anyway, I think you folks know how to load a session file. So if you go to File, right now it's hidden for me, but if you go to Vapor, File, and open a session, you should be able to bring that session into the graphical version and then continue your workflow from there. So, yeah, any questions?
I'm not supposed to.
It looks like you don't have a GPU. Oh.
I'm on Casper.
Yeah.
So I ran all the cells, like 1, 2, within this part here where it gets to the render. It doesn't give me this error.
Are you using a HVMC application?
No, so this started from the terminal. That's what I told you. Just open the browser.
On Casper?
Yeah, so here, where is it? This was on the slide, so I put Jupyter Notebook
Oh, I see.
and it opened the browser.
So I typically do it through I have a BMC window.
So you would do it through this?
Yes, so if you go to a console in this one,
Here.
yes.
Oh.
So if you go to a new tab.
No, that's it. Do I need to go to a new?
Oh, no, yeah, you're good. I thought there was some process running there.
No.
And then CD into the folder. Introduction, and then run Jupyter Notebook here. PYT.
Just that right there.
PYT.
Right.
That should work. That should open it in.
Because I didn't load Conda here, I did that.
Oh yeah, just to Conda install Jupyter, and this will also open Firefox and will create a window there.
I have a question. So are we able to do this on our local computers? I don't have a Windows, this is a MacBook.
Yeah, as long as it's not an x86 Mac, you should be able to.
Well, when I got to the Jupyter Notebook and imported the first box, and then when I start the session, it worked. Okay, it was not working.
I was looking.
How do you do this step here to get Google Drive onto Casper?
You just copy that link in any. If you open Firefox on the virtual desktop. So
on Casper.
VNC.
This one here?
Yeah.
Okay.
Open Firefox there.
Okay.
Paste that link there and you can just download those.
Okay, gotcha.
Any other questions? We can quickly move into the second example, which should be easier than this. So so with the second example, same process. So with this, we are taking an existing session file. So it's basically the session file that Scott has saved from the morning session, and then we are adding an interactive widget to it. So the first cell is essentially loading the required modules. And in this one, we are starting a session, and instead of loading a data set, we are loading a session file. And if you recognize the tornado.vs3, and by the way, in this case, you'll essentially point it to the sample directory that was, the sample data directory that Scott shared earlier. And again, it's a static image. We need to create an interactive window. So this is essentially where we left the tutorial in the morning. So here in the next step, I'm essentially getting the references to the volume and slice renderer from that session file. If you look at in your window, so is the name that I've selected is essentially, in this case, it would be volume. So if I were to create another volume, it would be, yeah, it'll create a unique name for it, and it's that name that we are invoking here. And over here, what I'm doing is I'm toggling the visibility of each renderer. We can hide the volume renderer because you can't see anything with this on. So I've disabled the volume renderer and making sure that the slice renderer is visible. So that's what this is. And the widgets functionality, you have a lot of options, but in this case, what I'm doing is I've created a callback function for what to do when a certain value is changed. So with every value that's changed, I'm adjusting the
offset value of the slice renderer. So going back to the graphical interface, okay, let me quickly add a slice renderer. Enable it. So if you recall, in variables, I think it's in geometry, yeah. So the slice offset moves your slice perpendicular to its, and you can move back and forth. So I created a callback function essentially to control the slice offset and creating a widget, setting the extents of the widget, and this part of the code is essentially adjusting where that widget should appear within the window. And yeah, that creates a widget, and you can create a tiny interactive that you can share with your colleagues. And yeah, essentially with these widgets, you can take any functionality of Vapor and create your custom widget to share with your folks. And that's pretty much it. I think I've shown two workflows, one starting with the Python API, taking it back to the GUI, one starting with the GUI, bringing it to Python API and extending it. So another thing we can do with the Python API is, let's say you want to extend the functionality of Vapor, you can create your custom functionality and you can help contribute to the open source effort. And that's the part that Ian is going to cover. So any questions till this part with the two notebooks? How are folks online doing? Okay, if there are no questions, then I think I can pass it over to Ian.
Yeah, hi.
Oh, just a second, Ian, we have a
So I just
question.
want a really quick comment.
Yep, go for it.
I was noticing it was taking a while for those widgets to kind of render.
Oh.
But they eventually came through, but I just had to wait a little while. Is that kind of usual? Or they weren't instant?
Is it for interacting with the widgets?
Yeah, so it would just come up with like this is a image like in a line
Okay.
of text, and then I'd wait a little while and it would come up. Have you seen that before?
I haven't seen that.
I mean, it's working, but
Okay, and I've seen with the widgets, like one tricky thing is I selected the slice renderer, that's probably the simplest of the renderers in Vapor. If you had a volume renderer that's changing some parameter, like with every move of the widget, it might take some time for it to render.
Okay.
So, yeah, you will see, it won't be as snippy as I've shown you for all renderers. Yes, Carl?
When we launch the Jupyter Notebook, what are we supposed to see?
You will see,
Look at this. That's after executing this command here.
okay, so this should be in the
In here?
Yeah. So over here is open console.
Okay.
And you can create a new tab.
Alright.
So you're running it from Casper.
Okay, so this is where the command is supposed to be
Yes.
executed. Okay, gotcha.
Any other questions? If not, I'll pass it over to Ian.
Yeah, I'll share my screen. I'll take over. Let's see if you can see this okay?
So,
I think so.
It's
Yeah,
good.
Bigger? Yeah, it's.
yeah, could you make it bigger?
I don't know if I can make it much bigger. That's,
Command plus.
is my square small? Is that the problem?
Yeah, actually the files are tiny, like the file names.
I see.
Oh yeah, there.
Here we go. Is that better?
Yeah.
Great. Okay. Yeah. Well, I'm going to be walking through two more examples. The first is going to be with loading X-ray into Vapor, and the second is going to be keyframing and a couple new features that are coming with Vapor 3.10. I'll start with our X-ray example. So how many of you are familiar with X-ray? Have you worked with it before? If you haven't, it's just a package that lets us handle multidimensional data sets. And it's a really powerful tool for working with a lot of geospatial data sets, like NetCDF. And so there's times where we'd want to look at a data set and edit it in X-ray, and then use that data set when derived variables in order to within Vapor. So in this example, I'll show how we can take an X-ray data set and visualize it in Vapor just like we've been seeing before. So first I'll run the imports, and this next cell downloads example data. It's not too big, so it shouldn't take too long. So the first step we'll do is load the data into X-ray with open dataset. You'll just point towards the file path. And there's a couple things we need to watch out for. We want to add our data into Vapor one variable at a time. So we'll start with U10, the 10-kilometer wind speed. So in X-ray, we just index our variable name, so we can select U10 out from a variable list. And you'll notice that we have 3 dimensions here: time, then like longitude and latitude, or spatial dimensions. We need to be careful because when we load things into X-ray, we lose some of the information of the data set. And so what this means is that Vapor can't determine if a coordinate variable is a spatial data set or a temporal data set. So if we try to send this data variable into Vapor, it will treat it as a 3-dimensional variable, even though we want U10 to be treated as a 2-dimensional variable. But that's a really easy fix. So we just remove time out from the data set. So now we just have our 2 spatial dimensions. And I totally forgot to run some of these cells. So I'm just gonna go back here and run them all again, just to be sure. Okay, so then the next step is to create a new Vapor session, just like we saw in the last example. And we'll add a Python dataset to this session. So this lets us use this command here, add X-ray data. It takes 2 parameters. The first is what we want the name to show up as within Vapor. And the second is the link to our data array. So what we just created here. And so if we run that, it works. And now we can just treat this variable exactly as we would in our previous workflows. We can create a new renderer. It's a 2D variable, so we'll create a 2D data renderer. And we'll set the variable name to whatever we named it here. So in this case, U10. Whoops. And then finally we can show, and we can see that it's showing up just like we'd expect. This isn't super interesting. So this is our Hurricane Katrina data set. So at the base, it's going east, and at the north, it's going west. But what we're really gets interesting is our 3D variables. So we'll take U, which is just the 3D version of U10, and we'll do the same exact process. We'll remove the time variable so that it's just our spatial dimensions. And then we'll add it to our data set. Did it again. There we go. Then this time we'll create a volume renderer. This is just going to be a big box. So what we should do is set our opacity values. So we'll mask out the middle values, so that we're just left with the extremely low wind speeds and the extremely high wind speeds. Did it work? Okay, this is what Nihant was saying. I ran one of these cells twice. So you have to be a little careful. It added two renderers. So what I need to do is start the session again. So I'll just run everything front to back.
How did you know you had two renders?
That's a good question. This is something I run into a lot. So what it was showing before, here we go, yeah. So here's our data set with the correct opacity values, and you can see the clumps of high wind speed either going east or going west. But if I run this cell again, oops, where did it go? I want to create the 3D renderer again. So now I created a new volume renderer without the new opacity values on top of the old renderer. So it's just overriding everything else. I don't know if there's a good way to tell for sure, but it's just something you need to watch out for if you're running the same cell multiple times.
So essentially like the change you made just didn't.
So yeah, the change I made with opacity values was on the most recent, whatever is assigned to the render Ren 3D.
Okay.
So I just overwrote Ren 3D with a new volume renderer. And so then I'm only changing the opacities on one of those renderers. So now we have one renderer where there's opacity values set correctly, and then another renderer where they're set incorrectly. And the easiest thing to do here is to just run everything again, just to make sure that you only have one renderer. And then I think that's it for X-ray. So the key points here, you need to watch out for removing your temporal dimensions when using X-ray. And then beyond that, it's working exactly like a normal VaporPython workflow. Does anyone else have any questions about this section?
I have a question. So if you have, do you need me to use the mic or can you hear me?
I can hear you, yep.
If you have a data set that has multiple time points, does that mean you have to compress that before using a Jupyter Notebook?
Yeah, so then once it's loaded into X-ray, there's no way for Vapor to tell what is a spatial dimension and what's a temporal dimension. So for that, we just recommend using the base loader, like how Nihant showed before, the normal workflow.
Okay, thanks.
Doesn't X-Array have that information as part of its metadata though?
Yeah, so sometime in the future, we could extend the functionality of X-ray, of our Vapor X-ray functions so that we'd be able to identify it. But a current X-ray loader is just going to treat everything as a spatial dimension.
Yeah, and honestly, the X-ray part is, we added it as an experiment to see how it's working to extent. So you folks will find things and we'd love to know.
Yeah.
And also, Ian, one thing I forgot to mention is the Python documentation. Could you pull up that web page real quick?
Yes,
On
the
API lookup.
yes.
So this is the API documentation. So this should have, I think with the earlier question about multiple renderers, there's one more option to query, and it gives you a list of all renderers that are there in the session. So that and all the other functions you can get a list. You can read more about them from the online documentation. It's not very evident, but
Yep, here it is, Git renderers. So that'll list everything that's there. And I'm guessing if I were to run this cell a few times. Where's my code? Yep, here you go. You can see that now I have 4 volume renderers when I intended to only have 1. Yeah, good point. Are there any last questions about X-ray before we move on?
This is Jupyter Hub. It's broken.
no questions in the room.
Okay, yeah, sounds great. Yeah, for this last part, I'll showcase some of the new features that are in Vapor 3.10. If you want to follow along, you can try downloading the newest version. It works on M1, but if you're on Casper, you might be having issues with it. But I'll show you from my own computer that's just in VS Code, the keyframing example notebook that's in the folder. The first big change from 3.9 to 3.10 is the way that the widgets work. So now instead of importing from Jupyter Vapor widgets, we're going to say from Vapor import widget. And so we'll start that import now, and then later on we'll use the new widget functions. This cell runs the same, or extracts the same Katrina dataset again. And then it'll be a little redundant, but we're just going to build a visualization up from scratch. The big idea for keyframing is that we want to create an animation within Vapor. So Vapor lets us capture different camera frames at different times and stitch them together to create a movie. So the idea here is that we don't want to identify every single camera angle in our movie. Instead, we'll pick out 3 or 4 or 5, and we'll linearly interpolate all the frames in between. And I think it'll make more sense once I start getting into it. But first we need a visualization. So I'm going to show how we make a visualization from scratch with this Katrina data. It starts with creating a session and opening our WorldView dataset that we just downloaded. And then we'll start with an image renderer. So we will call data.newRenderer, and then we'll signify that we want an image renderer. And this is what it looks like. And then we can set the height variable name to the Katrina's encoded land height variable. And it doesn't really change too much here because it's mostly flat, but next we'll add our U10 renderer. This is what we just saw in the X-ray dataset, but it's a little easier to do it in base Vapor Python. First we'll create a new 2D renderer, and then we'll point it towards the U10 variable name. And then here we see our new widget. So in Vapor 3.10, we'll call widget.vapor visualizer widget, and then link our session. And this works the exact same way. But there is an issue with this, and you can see that the image renderer and the 2D data renderer are on the same exact plane. So what we'll want to do is lift the image renderer up just slightly. We can do that by accessing the Git transform, the transformation settings of our land renderer. We'll then call set translations and just signify that we're lifting the z-axis up by a little bit. And there we can go over that. We can see that that fixes our issue. Next, we'll add our 3D renderer. So we'll point towards QCloud. We'll create a new renderer. It'll be a volume renderer. And we'll set the volume renderer to point towards our QCloud variable. And like we've seen before, it's going to be blue that doesn't look very much like a cloud. So we can access this renderer's transfer function. We'll call renderer dot get transfer function and list the variable that we are trying to edit. So in this case, clouds. And then we can access our built-in color functions with load built-in color map. So we'll do our black white, and this line just reverses it. So it goes from black white to white black. Let's run this. And then we see that we don't see very much detail here. But in 3.10, we have a new widget that can help us with this. You can do it in the Vapor GUI. You can change, here, what I'm trying to say is, we have a new widget that provides functionality similar to what you would see within the Vapor GUI within the transfer function widget. So we take vapor.utils.histogram and import our new transfer function widget. And then we will tell it the session that we're working with and also the renderer that we want to edit. And so we have our opacity control points and a histogram of our data values. So just like in the GUI, we can drag these points around and it'll update the visualization live. Once that's done, we can start with keyframing. So with our keyframing function, we want to capture a few different camera angles. And then Vapor's utility functions will take care of the interpolation for us. So the best way to do this is to save the camera positions to a file. So I provided some camera files already, but we can create some new ones. So what I'm going to do is choose the camera positions that I want within this widget, and then save it to its file and name it keyframe 1, keyframe 2, keyframe 3. So for our initial scene, I'll start up here. So we'll save the camera to a file and name it keyframe 1. And then you can see it pops up here. Then I'll go to my next camera position. I'll zoom in a little bit here. And then I'll capture a keyframe at this angle, and I'll call it keyframe 2. So what I'm doing is I'm building up our animation. So Vapor is going to interpolate all the frames from here to here, from keyframe 1 to keyframe 2. And we can do a few more. So I'll go beneath and get an angle of the hurricane from underneath. And then I'll get one more a view from the north looking south. I'll call that keyframe 4. now that we have our keyframes picked out, there's two more things we'll need. We'll need a list of file paths to our keyframes, and then a list of steps. This is a number of interpolated camera positions that our animation will have. I'll just rename these to the file paths that I just made. So keyframe 1 to keyframe 2 to keyframe 3 to keyframe 4. And then I'll create our steps array. This means that we'll have 40 steps between keyframe 1 and keyframe 2, and then 30 steps between each of keyframe 2 and keyframe 3, and keyframe 3 and keyframe 4. I'll run this cell, and then we can call another utility function. So from Vapor Utils, we'll import keyframing. And then we have this animate camera keyframes come from camera files function. It takes the session that we're currently working with, and then the list of camera files. And optionally, you can include the steps that we defined up here as well. Then if we run it, it'll create our animation, and it'll put together a movie for us. Okay, it's almost there. And here we are. So now you can see that it's taking the camera angles that I just picked out and interpolating all the camera angles in between it. And so then it creates this animation that goes from one keyframe to the next, to the next. Do we have any questions about this part? I went through a lot pretty fast.
Yeah, I have a question. So like, for example, if I have a different simulation, let's say it's the same domain, can I just change the file and use the same camera, the keyframes that I have saved before, for example? Or
Yeah, so these camera files aren't associated with a data set. It's just associated with the domain. So if two data sets have the same domain and like use the same values for the domain, then I think you would be able to use the same keyframes.
Theoretically.
Yeah, so then that's easy, because if you do this once, then you can replicate for whatever other case study you have.
Right, yep.
Yeah, and correct me if I'm wrong, Ian, but I think essentially you can take any session file and replace that data with any other data that you have. As long as they're geographically located in the same place, they should show up. And of course, as long as they have the same variables and everything, it should work.
Right, yep. I agree with that.
Have you tested this not on a Jupyter notebook, like maybe just Python or IPython? Is that gonna work? Like, can you have a streamlined process, like, let's say I have this process to create an animation, and so then, or do you actually need to render it every time? Can you do that on the background and then at the end I have a file just sitting there?
You're saying like as a Python script, like not in a
Yeah.
IPy notebook?
Yeah.
Yes, yep, you definitely can. The tricky part would be getting the camera angles right, but you can hard code it. You can call camera.lookAt here, and then you can give it the camera position, the camera target, and the camera up effector. So you just need to find the values for each of those, or maybe save your keyframes from the GUI. But yeah, you don't need this. This just makes it easier to make sure that you're getting the camera angles right before you save the file.
Awesome. Thank you.
So technically, you can run Vapor in like a headless mode
Yeah.
too. create your.
Have you ever seen the API have you ever seen the API not be able to find the widget module?
I ran into that too. It happened with you. It could be, yes, I know. You might be on 3.9.3. The widgets are there on 3.10.
Oh.
Yeah, so that could be. So yeah, the last portion of the tutorial, you need the latest version of Vapor. Just before the tutorial, we realized that it wasn't working on Casper and it had some issues that we are trying to figure out. So yeah, the widgets will be available in 3.10 whenever that's released. I think you had a question.
Not on Casper.
You had a question?
Yeah, my question had to do with time again. Say I wanted like a smoke plume changing in time and zooming in. Is that possible?
Yes.
Or can we do it with the Jupyter, or would it be more through the Vapor?
Yeah, so keyframing with Vapor, that's that's there in our roadmaps because that's a very often asked feature request. So that's coming. But over here, I think right now the examples that Ian showed has a single time step.
Yeah.
But if you go to the Pythia webpage that I mentioned earlier, that one has an example that Scott put together with the wildfire. It's from the East Troublesome wildfire example.
Okay.
Right? Because yeah, that one has the animation going as well as the keyframing. So it's both of them together.
But Ian, can't you increment time steps with the camera control that you just showed while keyframing?
Yes. Yeah, I don't know if you'd be able to increment it because it's within this function. But that would be
Okay, so we don't
maybe something to add to this functionality.
Got it.
So on the Pythia page, there is an example, but it's not using camera files, it's using sessions. So you'll save a session from one perspective, and then you'll linearly interpolate the camera through a function that is big, but it's like not a one-liner. And then that will interpolate the camera to the destination session at the end. And then within that loop, you can increment your time step.
So it's like you have a whole session that runs in time, like the smoke plume is doing this in time, and then the other session would be from a different angle, and then you interpolate that externally afterwards.
Right.
Okay, I think I get it.
And by the way, like all this part is essentially what we've extended the existing functionality of Vapor. In fact, the vapor.utils module that Ian mentioned, yeah, I think it's in cell 14, I believe. Yeah, maybe Ian, you can show that. That's the place where I feel we need your help. So if in your domain, if you see that there's a certain visualization pipeline that you folks use very often, that is something we can add to the Vapor Utils module and make it available for anyone who's downloading it. So that's one avenue where people can extend the functionality of Vapor.
Yeah, I actually wanted to showcase that a little bit. This is Vapor's GitHub repository. If we go to apps, Python API, Vapor, and then utils. A lot of these utils functions started as just scripts that built off of Vapor. So if you have a specific use case for Vapor and you write a Python script that extends functionality of Vapor, you can just drop the file into this utils package, and then other people would be able to use it too. So this animate keyframes function that we just showcased started out as just one big script that we've turned into a function and added into the utils file.
And that's probably, I think we need to have a contributors guide or something.
For this.
I think, yeah.
Yeah. We have a contributor's guide for the C++ side on the application, the GUI, but no one touches it.
I wonder why.
Yeah, it's hairy.
It's, yeah. Any other questions? If not, then I think I can wrap up. I have a few last slides.
Thanks, Ian.
Thanks, Ian.
Thank you.
Okay. Yeah, just a few resources for you to access after the tutorial. If you have any questions, I think at this point you folks know our emails and you know who we are. Reach out to us directly, or you can send an email to vapor@ucar.edu.
I would actually suggest using our forum. That way, everyone on the team has eyes on a ticket, and we can all see it and track it. With email, we end up forwarding, and it gets into this long email thread.
That sounds good. So yeah, let's do the forum. That's the second bullet point.
You're not sharing, by the way.
Yeah, can you share your screen and Google Meet, Liz?
Oh, I'm not.
You're
I
not
keep
sharing
getting-
online.
Sorry, folks.
No problem.
I have to join Google Meet. Alrighty. I have to find my tab. There it is. Oh. Yeah, so the discourse forum, oftentimes you will be able to find others might run into the same issue that you have. So you can search for an existing issue. If there isn't one, feel free to add start a new thread here. We are pretty responsive over here, so we'll respond to you sooner than you expect. But yeah, either way, yeah, that's one way to reach out to us if you have any questions. And you can access the Python API examples and tutorials through Pythia. I think I've shown that website before. And lastly, the Vapor documentation page is also useful. And Ian showed earlier, so if you go to, it has the class reference for the Python API. Like if you want to figure out, yeah, so you have Vapor, you have the Vapor session module. So what are the functions available in the session module? So you can look up all the options that are available. And before my laptop dies, yeah, and a huge thanks to the many contributors to Vapor. This project was started by John Klein a couple of years ago. And since then, we've had numerous software engineers and students contribute to the code base. We've also had a steering committee that's helped steer the direction of Vapor. And many of the example data sets that you've seen, we showed examples from Lee Orff and Pablo Minini today. If you folks have any data sets that you would like to showcase in Vapor, let us know. We always like to see like Vapor being practically applied, and with your permission, we can use your data sets as sample data sets in the future. And lastly, a huge thanks to the development team. We are a tiny team, but we do a lot. So yeah, I'm quite impressed with the stuff that these folks handle. So yeah, I have one last request for folks online and in person. If you're able to follow the QR code, it'll open a very quick survey on, we are basically asking your feedback on the tutorial and workshop. As I've mentioned earlier, it's the first time that we've done a day-long workshop, and we hope to do these more in the future. So your feedback will be used to improve the upcoming sessions. So, yeah.
Thank you, everyone.
Yeah.
Thank you.
Thank you. You're the one who did the heavy lifting, man.
Thanks, Ian. Thanks, Ian. And we're happy to stick around for office hours if you guys have data sets you'd like to ask questions about, getting your data loaded, or anything you'd like to do.
Do you have general office hours as well? Sorry if I missed that.
We've talked about doing that.
Yes.
But usually what happens is we get a request on the discourse forum and we can do a screen share.
Okay.
And just do them one-on-one that way.
But that's actually a good suggestion, because we did discuss having office hours. I've created the entire setup. I've never made it live because I didn't want to throw one more thing on the team. But yeah, that's something we should consider. You have one more way to join us. We started a user research panel for Vapor. I'll send the details in an email. So that essentially collects like some information on, yeah, of course, your contact information as well as like some of the features and data sets that you use Vapor with. So in the future, if we develop a new feature, we can reach out to you for a quick test, or we can collaborate with you on developing that feature. So if you folks are interested, I would definitely encourage you folks to join the user research panel. Yeah. Any other questions? Any questions online? No?
Just applause.
So are you gonna keep the folder as is shared? Cause I think the
For the
slides are
slides?
super helpful, yeah.
Oh, yeah.
Yes.
And we'll send the recording out. And that's all put together.
Would it help to combine all the slides in one slide deck?
I don't know, for me it's indifferent.
I don't mind them being separated.
Yeah.
Okay. I'm wondering if we should just upload them to our document.
Which documentation?
Oh, the documentation webpage. Let's
Maybe
think.
some links to the.
Yeah, I mean, yeah,
Yeah, yeah.
links to it. All right, well, we'll be here if you have any questions.